Good morning, everyone. Welcome to this year's Sharing Best Practice, which brings together experts from across the road sector for what we hope will be an engaging and a session on innovation, which I hope you'll find very, very exciting. I've been involved in the Asphalt Industry Alliance for 7 years, first as the General Manager for Eurobitume, and more recently as the group's chair. And it's been truly rewarding for me to have participation in sharing best practice, which has grown across the time that I've been the chair. We're delighted to tell you that this year's event is our biggest yet, with over 350 people signing up, including representatives from across 138 local authorities in England, Scotland and Wales. Welcome to you all. We hope you find today useful. Now, as ever, as we go through each of today's sessions, please do put your questions to our speakers in the Q&A section, which you'll find on the top bar of the screen. We do see this as an important part of encouraging debate and helping you to get the most from the day. So please share your thoughts with us, and we'll try to put as many questions as we can to those presenting in the time we have. However, a message to our industry attendees and colleagues. It is absolutely fantastic that you join us, and thank you very much for doing so. But we do ask that you don't use the Q&A feed as a way of promoting your commercial messages or your company. Now, understandably, the AIA needs to stay neutral on branded solutions. And as they say, other products are available. So please don't use the question and answer prompt for that purpose. Now, the sharp-eyed among you will have noticed that the logo here, which is on my probably my right-hand side to you, has changed. In fact, we have a special 2025 logo marking our 25 years since the AIA was founded. The group was set up in 2000 as a partnership between the Mineral Products Association, the MPA, and Eurobitume to promote the uses and benefits of asphalts to specifiers, policymakers, and the general public. And it continues to thrive, I'm very pleased to say. Over the past years, awareness of the AIA has grown, and I'm proud to say that I've had an opportunity to play a part in the AIA becoming an authoritative and independent voice on asphalt industry issues, and that our association has grown through that time. One of the AIA's best known activities is publishing the annual local authority road maintenance, the alarm survey, and we use its findings to emphasize the importance of having increased, sustained and targeted investment in the maintenance of our local road. And there's no doubt that alarm and the trends over 30 years of having consistent data has become integral to the national debate on road maintenance and conditions. For example, this week, our communications team at James Reed PR have been handling inquiries from the Sunday Times on rates of road resurfacing. And recently, we've also been liaising with a renowned documentary makers on road maintenance for a forthcoming TV programme which should be aired in December. So you may have the opportunity to see the AIA on the TV. As we've said many times before, we are indebted to those of you who contribute to the alarm survey's success and to the success of the AIA by providing data and participating in our focus groups, allowing us to develop this robust and influential report. This year, Alarm 2025 had its highest ever response rate. So, mindful we couldn't do it without your support, we thought it was important that in our anniversary year, we mark the contribution that you all make, and thank you again. This is why I'm delighted to announce the introduction of a special Alarm Appreciation Award and its first recipient. I'm going to do a drum roll here. And the first recipient is Donna Kelly, the service manager at London Borough of Hammersmith and Fulham. In her role as a previous chair of LOHEG, the London Highways Engineers Group, Donna was a strong advocate of Alarm, encouraging involvement and allowing us to share the London-only findings with her group. Thanks in no small part to Donna's support, we've seen response rates for our alarm survey across the London boroughs increase significantly over the recent years to an all-time high now of 78% this year. So Donna, thank you very much indeed for your support. I'm supposed to have your award here with me, but things conspired against us, and I'm afraid the courier has let me down. So I do apologise for that. So in time-honoured fashion, I'm going to hand over to you and pretend that I'm handing an award over to you, which will come to you in the post very soon. But Donna, congratulations, and please a few words from you.
Thank you so much. It's been a bit of a labour of love getting everyone on board with the alarm survey, but I'm so thrilled that we've been able to get the numbers up over the last few years. And I'm sure that now that I've handed over the LOHEG reins to Daniela, I'm sure that she will carry on and hopefully we'll get it nearer to 100. In my role at Hammersmith and Fulham, it's just so important. You know, the cabinet members love quoting the alarm survey, and it's really important that Hammersmith is part of that. And I know there are a few boroughs that are maybe a little bit nervous about taking part, and we've tried to pull them along with us over the years. It's really difficult if your cabinet members are quoting something like the alarm and you're not taking part. So with all of these surveys, like the State of the City survey, the alarm survey, and everything for the DFT, if you're part of the conversation, then you can use that data as well to try and persuade the powers that be to give you a bit more funding. And I think probably everyone on the call could do it with a bit more funding in their authorities or organisations. So yeah, this is a great award. Thank you so much, and hopefully continue to work together in the future.
Well done. Thank you, Donna, very much indeed. I'm so pleased to hear that the report is used and shared widely within your organisation. So your appreciation award is on its way to you. I promise you that. And we look forward to next year and seeing who will be the recipient. Now, in addition to the alarm survey report, another key area for the AIA is our support of the all-party parliamentary group for better roads. In conjunction with the Institute of Highway Engineers, we provide the Secretariat services to the group and have also helped inform the development of the APPG's reports into warm mix asphalt and more recently the effectiveness of the Pothole Action Fund. Following the general election last year, the group has formally reformed with new officers, which was required under the current parliamentary rules. And we have a new chair, Rebecca Paul, MP. Before entering the House, Rebecca was previously a councillor for Surrey County Council, where her work included a launch of a fairer road funding campaign. And she's also been involved in the Public Accounts Committee inquiry into the condition and maintenance of local roads in England, which was published earlier this year. Our initial meetings with Rebecca have been extremely positive, and we're thrilled that she sent us a message about her aims for the APPG so that we can share them with you today. So, over to the video, and I hope that technology won't fail us. Well, a big thank you to Rebecca for taking the time to record that message for us and speaking to us all today. And of course, we agree that innovation only brings change when it's shared successfully, which of course brings me very neatly on to the focus of our Sharing Best Practice event this morning. We'll hear shortly from industry experts, as well as some of your peers from local authorities across the country. We will examine the role of materials and technology, many of which are tried and tested and readily available right now. And of course, these materials can play a vital role in helping to ensure our local roads are fit for the future. To kick off, I'd now like to hand over to my AIA colleague and Eurobitume Technical Director, Dr. Ian Lancaster, who is reviewing asset management in the time of climate change. This will provide a valuable backdrop as we go through today's agenda, looking at the ways in which our sector can help reduce whole life carbon and improve durability and mitigate the challenges that we face ahead. So over to you, Dr. Lancaster.
Thank you. Thank you, David. Welcome, everybody. I'm just waiting for my slides to load up. Here we go. It's great to see so many people attending today. My role is to really set the scene for what you're about to hear over the next couple of hours. And I'm going to talk about how we manage our asset in the time of climate change. Great to hear from Rebecca that our local road network is the single most important publicly owned asset that we have. And I always like to start with a question. So are we heading really for a perfect storm? Before we start to do that, we could probably need to define it, really. And we can look at it in two different ways. One, looking at the climate itself, a rare combination of meteorological factors. I think it's probably true that we're heading that way. You know, we're seeing a lot more extreme weather events, but are we in an especially bad situation caused by a combination of unfavorable circumstances? I think the answer to that is almost certainly yes. We have to consider what is going on with the changing climate, its effects on our local road network, and the crisis that we have in funding, as highlighted by the Alarm survey. So what are we facing? You only need to look at the newspapers. If you still read a newspaper, look at Google, search the internet, look out of your own front windows to see some of the extremes that we're facing. Regular flooding. We've started naming storms, short, sharp, incredibly cold winters, and also very, very hot summers, and leading to wildfires and the associated high temperatures that we see on the road network. And what does that combination of meteorological factors do, or what can it do to an aging, underfunded network? Well, again, we only need to look outside our own front doors to see excessive rutting where we've got a lot of heavy vehicles and a lot of standing traffic, cracking of the network, wholesale delamination. So faced with all of that, what can we do? Well, we'll come to that in a little moment. So I heard a very interesting quote the other day. When people talk about climate and they talk about weather, what do the two mean? Well, climate really is what you expect, and weather is what you're going to get. So we're seeing, it's pretty much undeniable what we're seeing. Increases in temperatures in the summer, a lot of excessive rainfall, very, very heavy rainfall, high winds, storms, and all sorts of other factors. For any skeptics that are amongst us, I'm just going to highlight some things that are out there. Carbon dioxide in the atmosphere is going up, sea levels are rising, surface temperatures are increasing. You can look at that report. It's very, very good. I would recommend it. So the evidence is pretty much undeniable. We are facing serious issues. What does it mean in the UK? Well, if you look at if you look back over the last 20 years, what have we seen? In 2006, we got road surface temperature, air temperatures, sorry, in excess of 35 degrees, and you're almost setting your clock to ask to wait for when the local news bulletins are going to say the roads are melting, the roads are melting. Wind it forward to 2007, we had excessive rainfall. The picture that you see there is in the main road into my hometown. It's the A63 going into Hull. It flooded badly twice. 3 years later, we got record low temperatures. Again, that's the road outside my house, minus 15 degrees for a prolonged period of time. Roll it forward to 2018 and 2022, where we saw the highest temperature ever recorded in the UK of 40.3 degrees. The evidence is there. We know that local authorities have set climate emergencies. 80% of authorities have declared climate emergencies in their region. But only 10% of those authorities have a plan to reduce carbon through materials. Now, and it's a sobering fact as well that if we were to stop pumping carbon dioxide into the atmosphere right now, it would not immediately go back to where we were 30, 40 years ago. So there will be a delay. So what can we do? If we can't change the climate change, what can we do? Well, we can do a number of things. The single most important thing we can do is improve the resilience of the network, make it more resistant to the climate change. We can equally, within our products, and you're going to hear more about this today, we can reduce the carbon associated with our product, which is part of the global effort to reduce carbon. And it's important to understand in all of this that both the binder and the asphalt have a role to play. So how can we mitigate the effects of climate change? Well, we can produce more resilient binders, and you're going to hear more about those today. We're talking about polymer modified binders, which give us better performance. They last longer. They have a much wider temperature envelope, so they're not affected by the extremes of heat and cold. And so they're going to be more resistant to the increasing temperatures and the short, sharp shocks of low temperatures. So they're going to be much more resistant. We can reduce the temperature of application of our binders and our asphalt. That means we're reducing energy, we're reducing emissions, we're using less fuel, we're pumping less carbon dioxide into the atmosphere. We can use the asset that's actually on our doorstep. Asphalt is the single most recycled material in the world, more so than paper, more so than steel, more so than glass. And so we can increase our use of recycled asphalt pavement to make sure that we're getting the maximum effective use of the resources that we had. We're also going to hear today about low carbon binders. There are steps that we can take and things that we can change to reduce the embodied carbon associated with the bitumen, and that reduces the embodied carbon associated with the asphalt itself. We can make permeable pavements. We can manage the water course. We can manage the effects of flooding by including sustainable earnage drainage systems and introducing water management. And we can then optimize our maintenance techniques. Rather than having the situation that we're probably all in at the moment, which is in reactive maintenance, we can plan and preserve the asset, go for full proper preventive maintenance, and that maximizes the asset life. And if it maximizes the asset life, the carbon associated with it goes down. So we're all doing our part. And then it's happening now. We can bring in emissions reduction techniques. The technology is out there. We heard some success stories about it last year at Sharing Best Practice about the use of electric pavers, rollers, trucks, etc. We should never within this industry think that we are not a forward-facing industry that is determined to react and move forward. So I'm going to move on to some case studies in a little while, but let's just give a snapshot about what polymer modified binders can do. As I said, they improve the high temperature performance, means you've got to work harder to get them to deform and to flow. They improve the low temperature performance as well. You've got to go to a lower temperature before you can induce them to crack, and they're also much more flexible. People say to me, what about the cost? And PMB, yes, generally speaking, a PMB does cost more in the short term. And there is more carbon associated with a polymer modified binder in the short term. However, we know that we can extend the life of a road by using polymer modified bitumens. The data is there, it's out there, it's real. So That then leads us to fewer maintenance interventions. And what you find is the long-term gains outweigh those short-term costs, both in terms of price and in terms of carbon. So it really is a win-win. In terms of temperature reduction, we can go from our conventional hot mix to warm mix and even cold mix technologies, reducing emissions, reducing energy demand. And we also got to take into consideration that this leads to much better working conditions to the guys, to the people that are out there actually handling the material and laying the pavement. And just to finish, what can we do in terms of water management? Well, sustainable urban drainage, porous asphalt. Yes, it requires effort and maintenance, but the benefits are there. So what I've tried to do is to give a little snapshot of where we are in terms of carbon and what technologies that we have available to us. It's fine for me to give you this as a theoretical kind of overview, but it's not theoretical. So now we're going to hear from three experts in the industry. The first person I'm going to hand over to is Alan Ferguson. I've known Alan for a long, long time. He's the materials advisor at Transport Scotland, and he's going to give us a perspective on a material called TS2010, 15 years on. So, Alan, I'll hand over to you.
Hi, and good morning to everybody. I'm just waiting for my slides to pop up. Are they there yet? Right. So thanks for the introduction, Ian. Yes, we go quite far back now. It's scary. We better not count. Moving on to the next slide. What I want to talk about is TS2010. It is a dense stone mastic asphalt. It has a target binder content of 6.7% for a 10 mil. That binder content is heavily polymer modified, and picking up on Ian's point, the heavily polymer modified bitumen has a softening point of 75 degrees, which is quite nice when the hot spells come through. We've now been laying it in significant tonnage for over 12 years, and about 40% of the trunk road network is now TS2010. So we are quite keen to understand the life that is being achieved with this material. So we're trying to understand life in two different ways, and one of them is through a visual inspection process. Now, there is a procedure set out in TRL 674 for visual assessment of materials developed by Cliff Nichols back in 2010. And he looked at lots of different sites with his team and plotted visual condition against age of lots of different materials and came up with a deterioration curve. And you can see the bottom curve there. And what it says in that report is if you lay a material in good weather conditions, it's in specification and it's properly laid, you can expect a life of between 14 and 15 years. And that was based on looking at the state of different surfaces at different ages and correlating them along this theoretical deterioration curve. So we've now been doing visual inspections of TS2010 for over 12 years now. And what we did was we commissioned WSP to collate the results of over 200 different visual inspections against state and age and come up with a deterioration curve to see how our life to replacement was comparing with the original 942 thin surfacings. And this is the curve we got here. And if you can't see the small print at the bottom, it's looking like life will be on average about 20 years based on that work. It was Michael McHale of WSP headed up that research, which is available on the Transport Scotland website. If we move on to the next slide, The other way of looking at the age of materials that is actually being achieved is to see how much is down on the network and how much has been replaced at different age. And this is a quite recent work that I've extracted from the Transport Scotland pavement management system. You look at all the material that's over 5 years old and how much has been replaced by something else at the age of 5 years, 6 years, 7 years, 8 years, and you plot the data on a graph. So for example, at 5 years old, all the material laid, something like 3.4% had been replaced by something else at 5 years. So you plot all the different points on the graph and you begin to get this deterioration curve. And it's quite nice in theory, if you think about it, as it gets older, more material will get replaced. But you can extrapolate from this, and the average life of material, my theory suggests, or my thinking has come to the conclusion that it's where it's about 50% of the materials left, a bit like the average age of people. 50% is when half the folk have died, and 50% is when half the roads have been replaced. And if you extrapolate, depending on the curve you use, we're looking at something between 16 and over 20 years life for TS 2010 based on real data from our pavement management system. So I just wanted to show those graphs to show that if you go for high binder contents with polymodified binders and fibres in a dense mix, you can expect to achieve significant and real extensions in life. And that was the 2 points I wanted to show today. So I'll hand over to the next person, Neil.
Yeah, thanks, Alan. Thank you very much. Just a quick reminder, everyone, if you do have any questions, please pop them in the Q&A and we will pick them up. It's an interactive session. We do want to hear from you. Any questions, comments, please pop them into that Q&A. So next up, we've got Neil Bromham, who is a pavement engineer pavement materials engineer with the Welsh Government, and he's going to highlight some of the successes of the approach on the Welsh network. Over to you, Neil.
Good morning.
Morning, Neil.
Morning. I'll just wait for my slides as well. Oh, hi there. Okay. Good morning, and thanks to the AAA for the invite. To provide some background, I moved into Welsh Government in 2015, where I work in the pavement team within the Network Management Division. But at the time, my colleague, I had no idea of the condition of the SRN we were about to take over. How do you get on the next slide? Yeah. Using the standardized combination of tech survey data and visual surveys, we achieved our first priority, and now we're in a good place of knowing the condition on our network, which is now on our pavement management system. And the next challenge we had is we realized we couldn't keep on top of asset deterioration, decided to change the materials we use to achieve greater durability. Primarily, we use SMAs like Alan has just displayed by TS 2010. And we also use a lot of HRAs, including 30 to 35 14s and 55 and 5510s in rural locations, as well as cold applied ultra-thin surfacings or surface dressings, for those of you who know what does that. Where overall this approach has been successful, but we do still experience common issues such as cold end of loads and examples of poor workmanship, which for me is the opposite of best practice. And what is the point of us being here? Because these are actually easily preventable. I raise these issues with the Wales Pavement Forum, where we work collectively with the industry in Wales to rectify, to deviate slightly. One topic is being discussed as a forum is that of recycled asphalt planings. Asphalt has already been said is 100% recyclable, and the benefits are clear from the side. Our problem with Wales, though, is that our RAP quality is poor in places. I don't know where. So poor in places. Just get my point. So we have to sort of slightly deviate then from the current standard in the British standards in PD 6691, which led me then to spending 4 days in Germany and learning from their process that allows an annual average of 30% RAP addition based on RAP quality, consistency, and plat capability. This led to Welsh Government's first RAP trial for over a decade in 22-23, where the addition rates are based on German methodology, which is on the slide. But at the time, this led to the carbon savings of about 1 to 1.5% per tonne. Fast forward now to the carbon value for bitumen significantly increasing. We started a trial RAP in SMA, firstly at 5 to 10% and then up to 15%, where the CO2 savings have increased and the figures you can see on screen, and the quality of material doesn't appear to have diminished and is well within our current specification. But as always, the journey continues. And thanks.
Thanks a lot, Neil. So we've heard from Scotland. We have heard from Wales. Next up, we're going to bring in Paul Edwards, again, someone I've known for a long time. Paul is the head of pavements with National Highways. And Paul is going to give us an outline of the approach within National Highways to the strategic road network. Over to you, Paul.
Thank you. Waiting for the slides to come up. So first off, good morning. Thank you for inviting me along. As a whistle-stop tour of improving durability, I think the key thing is this is sort of repeating or echoing what other people have said. Durability, how long asphalt surfacings last or road surfaces last, absolutely aligns with all our imperatives of safety, customer and delivery. They're a key driver, they're a key focus for us to actually improve or continuously look at improving. How do we do this? Well, one of the drivers is updates to standards. So for those of you who are not aware, there's been a major update in 2025. We've got new documents, new structure, content. It took us a while to actually implement these. So there's been a bit of a sort of a 2-3 year plus hiatus. But I'd encourage anyone on this call, the link to the new standards page is there. The two key documents, if you want to see the content, CC 204 is pavement surface treatment, so that includes surface dressing, and CC 205 is maintenance of pavements with asphalt surfacing. That document includes a evolution of the thin surface course specification. So there's revisions in there, both linked to durability and also to sustainability, including a potential increase of reclaimed asphalt from 10 to 20% in there. There's also a brand new surfacing. It has been trialled a number of years on the English SRN. It's a SMA-based product. It doesn't permit reclaimed asphalt. It doesn't follow a third-party certification. And it does have a framework for actually specifying what type of P&B you want in there. So those documents are there. It's also worth reflecting that actually since 1998, there's been about 15 updates to the asphalt content within the specification for highways work. So this is an area of continuous development, always has been and will continue to be. In terms of our direction of travel, going beyond specifications, Neil mentioned it really well. We're with big focus on pause for quality. We've already got specifications, we've already got materials being used. We need to get the most from them. There's no point spending extra money on trying to get things to last longer or reducing carbon if you're not actually doing the best job with what you've already got. So there's a big initiative going on, pause for quality. The primary focus is on, in terms of National Highways network, how can we get the best results? And a lot of the time we're having to lay asphalt, maybe not in the best of weathers, at night. So that's a key focus for us. Adaptation, resilience, as Ian mentioned, in 2022, along with those air temperatures, we've got road surface temperatures in excess of 60 degrees. And then we have a working range down into the low minuses. So we're getting potentially a 70-degree working range that we need our asphalt surfaces to perform in. So there's a review underway on that. The strategic road network is relatively resistant as far as our materials go, but certainly early life and with the frequency of heat waves increasing, there are discussions in terms of our direction of travel. Do we move away from, for example, from 40/60? Do we make PMB as the first choice option going forward? those things are under review and under discussion. Net zero for construction and maintenance, sort of the flip side, as Ian mentioned. We have had our first net zero scheme constructed in north of England, pavement renewal. There's a lot of innovation in this space. Again, if you go to Standards for Highways website, there's a link to other resources which show which low carbon opportunities have been included in the new specification. And we're doing a lot of work on future ones, which you'll hear about later today. And then the last bit I just wanted to mention was we've got a challenge-led innovation out at the moment for RIS3, so that starts April next year. In terms of pavements, our focus is on adopting technology. So it's about improving safety, removing technicians from the network, but also some of that technology gives us much more granularity rather than measuring sand patch on volumetric, see what our road surface textures at 10 discrete points. We've now got technology that can give you a profile of the whole mat and things like surface regularity as well. So we're looking at technology both from a safety point of view, but also from an improving quality point of view. That's it for me. Thank you.
That's great, Paul. Thank you very much. So I'm going to bring everybody back onto screen now, and we're going to open it up for questions. Thanks everyone for really, really good overviews of what's happening in your networks. So if I could start the ball rolling, interesting, slightly different approaches to the whole question of durability, resilience, etc. What opportunities do you see for further collaboration in this area? Or is the fact that we're all in devolved administrations causing a little bit of an issue?
I'll start if you like. So, I mean, the first thing is the standards board includes all three of us in there. So the standards are very much across everyone on this, or in terms of nations on this call, plus Northern Ireland as well. We also share a lot of experience, and there are some slight differences in approaches being taken, a lot of cross-learning on that. When it comes to climate change, I'd probably say south of England's got higher risk of heat waves, but it doesn't mean in the north of England we're still getting heat waves, and we've still got road surface temperatures in 2022 of 60 degrees. It's just the frequency is lower. So there's a lot of sharing going on. It can always be improved. And certainly with local authorities, we share information via ADEPT, LCRIG, etc. as well, especially on low carbon.
Yeah, I would agree. The standards boards that meet are all the devolved administrations and National Highways, and we chat, and I think we've all got a good working relationship, and we do work together and share information, and that is vital, and not just with ourselves but also with the supply chain. So the approval processes for innovations are slightly different across the different, but then that's appropriate because we are in different landscapes, literally and metaphorically.
Yeah. Okay, so we have had a couple of questions that have come in through the Q&A. First one is from Greg Collingridge. It's directed, I think, towards you, Alan. Regarding the TS 2010 curves, were the percent removed yearly amounts or were they cumulative? It showed last year's being 10.2%, 10.1% each being removed. Is that a total of 20.3? If not, how is the percentage removed? How does it reduce?
So good question, and I'm impressed that you spotted the 0.1, 0.2 difference there. Greg, well done. So what you have to do is it's not as straightforward as you might think to extract the information and then get the right data for each year. What you have to do is you have to find all the material that has reached 10 years old and then see how much has gone at 10 years. And that's what was reported. So the 10% value was the total for 10 years. And then you move to 11 years. And of course, at 11 years, if you think about it, there's a lot less material that is reached 11 years old because it wasn't laid in 2012 or 2013 or 2014. It's a smaller tonnage, and then there's a different tonnage that has been removed. So that's why you can get variations. And as you spotted, there was slightly less removed at 11 years than at 10 years. That's because it was a smaller amount of material that was 11 years old. So those figures are all cumulative figures, and it feels like we need a methodology for implementing that kind of analysis that we agree across the network, so that we can all work out our age of materials to average life of materials, and have a standard method of calculating it for that kind of detail to make sure it gets ironed out. I hope that answers your question.
It does. This question for everybody, really. This is from Christopher Nelson. What advice would you give to local authorities with large rural networks? Obviously, the three of you have spoken more specifically about developments on the strategic road network. So would you say that the PMBs and the SMAs that you're talking about are suitable for a large rural network?
Can I go?
Yes, sure.
I think it depends where you are on the network, Ian. Obviously, the rural network can sometimes go through little towns and little villages. I think you've got to be sort of careful then of maybe where you would put more other sort of preventative techniques like surface dressings and courts and things like that. But I think having a good preventative program is probably the key of holding that network together.
Yeah, good. One for you, Paul, from Dharmendra Rajput. Both the DMRB 224 and 226 have been superseded. Is there new documentation replacing these?
Yes, so the key thing with the new specification that's come out is it's directly linked to the DMRB. So the DMRB is the designer documents, specification is the contractor. All the DMRB has been rewritten because the DMRB now has design output sections, and those design output sections then link direct to the specification. So for example, the designer chooses to go, do I want my surface course to have 4060 pen or PMB? And then that is then called up by the specification. So yeah, all the DMRB has been updated and the documents now sit side by side.
Good. Interesting question from Rob Hudson Griffiths here. This is about our assessment methods. In the light of rising ambient temperatures associated with climate change, should the test temperature for assessing permanent deformation, so wheel tracking, which is currently set at 60 degrees, should that 60-degree surface temperature go up? And should we be setting specifications around a higher temperature?
I would think 60 degrees is probably hot enough, personally. It's, once the road's trafficked, it's not a bright black shiny road. It doesn't reach much above 60 degrees. Certainly not in Scotland.
Anything from Paul or Neil on that one? I'm going to need to wrap this session up pretty quickly.
I don't think it needs to be increased, to be fair. And as everyone's alluded to, a lot of the bitumen we use in our SMAs now has got a pretty high softening point. So how hot do you think the world is going to become, I suppose?
National Highways point of view, it is something that could be reviewed, but it's okay. Sorry, I broke up there, Ian.
No, that's okay. That's okay. Another question from Greg Collingridge to you, Neil. Is the German method different to British standards, and there are plans to update guidance? This is, I think, in relation to RAP usage. Are there plans to update guidance to provide more consistent guidance?
As I tried to allude in my presentation there, we have some sort of very low pen wraps. They were coming in around about 15 to 18, which is extremely low. And, if you're going to go out into the continent, they would be downcycled and into bases and binder courses. We've also had very consistent wrap stockpiles that almost allow for a greater sort of percentage to be put into asphalts. But then we haven't necessarily got the plant capabilities in Wales. We're lucky if we have got a cold feed, it can probably get about 20% in maximally. So it's a work in progress, and we will work via our pavement forum in order to sort of try and get something that suits our situation over in this part of the UK.
Okay, right. Thank you very much. So, really good opening session there from the three of you. Just one last question from me before I hand over to the next section. If there was one key takeaway from this session that you think would be most important to our local highways engineers, what would that be? And I'm going to go, right, Neil, I'm going to go to you first.
I think I've already said in is having a good preventative maintenance program.
Yeah, Alan?
A decent binder content in your asphalt, I would suggest.
And finally to you, Paul.
Right material, right place, right time. So links into asset management and decision making and getting the best quality out of it.
Exactly. Right. Thank you so much once again to Paul, to Alan, to Neil, and to you that are online. I'm now going to hand over to Malcolm Sims, who is going to take us through the next session. So thank you again, and over to you, Malcolm.
Apologies, I've muted myself in the wrong place, couldn't find the button. Thanks Ian and others for that informative session. So what we're going to look at now is some more work around the mitigation phase, the mitigation phase of how, as an industry and clients, we can progress to using less or producing less CO2 in our products and solutions. So I'll quickly introduce some colleagues who've done some research work, primarily for National Highways, but you can forget the application. Look at the results. So first up, we've got Donna James, and as with others, I've known Donna for quite some time. I think we're clocking up over 25 years now, Donna. So I first met Donna when she was at TRL, but now she's a fellow for pavement engineering at AtkinsRéalis, has nearly 30 years experience in the industry, is a fellow of the Institute of Asphalt Technology, fellow of the Chartered Institution of Highways and Transportation, and an ICE, Institution of Civil Engineers, Carbon Champion. And she's an active member of many of the British Standards committees that we both sit on for road materials. And in the last 5 years, she's specialised in research in low carbon asphalt materials. Gordon, I've known again over 20 years, I'd suggest. And Gordon is currently director of the Nottingham Transportation Engineering Centre, or NTEC, and professor of pavement engineering materials at the University of Nottingham. He's been actively involved in laboratory testing and performance characterisation of biogenic asphalt materials as part of the National Highways, SPATS and DFT ADEPT Live Labs decarbonisation road material trials. And I guess that's what you'll give us an update on. Thanks, guys.
Thanks, Malcolm. Right, over to me then, I think, to start us off, although I was expecting an extra button to press, so let's hope that things happen when I try to move the slides on. So as Malcolm introduced, myself and Gordon are going to talk about low carbon asphalt using bio-based binders. I'm going to try and keep the jargon down in this presentation. You will have heard lots of phrases flying around this topic. We're going to try and keep it simple here because there are lots of products that might fall under this banner of bio-based binders or biogenic binders. As I say, you will have heard lots of terms. Specifically in this presentation, we're going to talk about bio-based binders that are produced at a binder production facility. So that is something that comes to the asphalt plant pre-mixed into to the base bitumen. We're not going to be talking about innovations where things are added at the asphalt plant. There is lots of research going on around that too, but we thought we would keep it simple in this presentation. Oh, it worked. That's great. Okay, so why are we here? Where did we start? Paul alluded earlier to the net zero highways plan for national highways, and the key figure that we need to take away from that is that national highways have committed to net zero carbon for maintenance and construction emissions by 2040, and that is, real net zero. There's a very small amount of that can be achieved through offsetting, but we're actually really talking about delivering, and 2040 is not that far away. So some serious work needs to be done to make sure that we can achieve that target. We were fortunate enough at Atkins Realis, alongside a big team of people that you'll see later on, to be asked to help National Highways with this research, and we very much focused on asphalt surface courses. So we're not looking at binder and bases here, and that statistic's a bit old, but in 2020, 63% of all the asphalt used on the strategic road network was in the surface. And again, often we don't have the funds and the resources to be looking at maintaining those lower layers. So the surface course is really where we can make the biggest difference. So probably a key thing about this particular approach is we've tried to buck the trend a little bit, and we've tried to compress all the type of work we do into quite a short period of time, rather than that long drawn out process that we usually use for research. What we've done is we've taken a holistic view, because, as I said, 2040 is not that far away. So it's no good laying trials that need to be down for 10 years. It's no good waiting till the end of that process before we think about how we might specify and introduce those low carbon materials. And it's no good if we focus on materials that don't give us the biggest bang for our buck in terms of actual carbon reduction. So you'll see across the bottom there, all of those elements of the project have effectively happened in parallel. So we looked at what was out there, we reviewed what had already been done on the strategic road network. Gordon is going to tell you all about some of the laboratory assessment that we've been doing. We've obviously looked at the carbon in whole life and initial terms, and we've done that standards review and looked at the technology readiness level of the various low carbon materials that have come to our attention. As I say, collaboration has been really, really a massive part of this project, and that is what's made it a success, essentially. So in terms of the materials that we're going to talk about today, those are the ones on the main part of the slide, but you can see that lots of other parties have been involved with other innovations. This is a big area, and I think it's only going to continue to grow. So those people are involved in right across how we've done our work, whether it be the laboratory testing, as I say, at MTech, or producing mixed designs, actually installing and laying the product. So just a big thank you to everybody who has been involved in the project so far. So in terms of the material testing, Gordon's going to run you through some results later on. But as part of this process, as I say, what we need to try and do is accelerate things. And the best way we can do that is to, in my words, throw the kitchen sink at it. So there isn't a magic test that we can use where we put a sample in a machine and it says, yep, this asphalt's going to last 15 years. It's great. As Alan showed, we need to wait for data to come through. But the carbon agenda means that we don't necessarily have the luxury of time. So we've got to find a way of doing that. And whilst we don't know in terms of absolute numbers often for a lot of these tests, what would be a good product or a poor product, what we do know is we've got a vast database of information for a lot of these tests because we've been testing asphalt materials for years. So we can compare these new products, these new innovations against established data. But I'll leave it to Gordon to tell you about the actual detail there. So what have we done so far? Well, the first phase of this was to lay a trial down on the A30 in Devon, where we laid 2 of these PMB bio-based binders. So it is polymer modified and it does have a biogenic component. Okay, into a thin surface course, a clause 942 material. It's the strategic road network. We started simple. These were hot mix with no reclaimed asphalt at all. And obviously we installed a control material so that we could compare performance in the future. This was a first on the strategic road network. And because of that, it's obviously not covered by standards currently. So we did need a departure from standards. So that trial was a huge success, and the material was laid. There were no hiccups. It's in great visual condition now, so that's all gone really well. But from the carbon calculations, whilst this was a big step forward, we realised that this was not going to solve the problem on its own. So the way to try and address this was to look at what's been termed stacking technologies. So what we're trying to do now is bring to bear some other decarbonisation levers that we know about, and to see whether they could work in combination with these PMB bio-based binders. So we had 2 trials where we specifically looked at this, one on the A2 in Kingston and one on the A34 in East Ilsley. So the first trial on Kingston, we blended the bio-based PMB with a warm mix additive. And then we also used the same mix, but included 20% reclaimed asphalt. And that 20% was taking in view of what Paul talked about earlier, that should become the norm under the new specification for highway work. So that's that step up from 10%, which we would expect currently. Then a second trial, we took that one step further. We went to the A34, the same process, but then we just eked it a little bit further and looked at the addition of 30% reclaimed asphalt. And what this has shown us is, again, mixing and laying could be done quite comfortably, no issues in the installation. It did rain all day on the A34, but you can't have everything. And what it showed us was that, in fact, the carbon savings, when we take some things that we're more comfortable with, that we've known about for quite a while, inclusion of RA and warm mix additives, that we can actually blend these with these further low carbon products, the bio-based polymer modified binders. Now, just for clarification, again, there's been a Eurobitume document published recently. There's lots of terminology. In these sorts of materials, we're looking at probably around 20% biogenic component in those bio-based binders. So I think under the new terminology, that would be called a bio-extended binder. But just to give you a feel for where we're at. So it's not 100% biogenic component. It still has a significant amount of bitumen in. But obviously, work in the future might look at how we can adapt that. So just finally, before I hand over to Gordon, obviously in the future, we need to be able to specify these materials. So essentially, what we're looking at for these, because they are based around a standard PMB, albeit with a biogenic component, is that there's the opportunity to specify them much in the same way as you would a polymer modified binder. So using the classes that you would use, if you've got a PMB that you're comfortable with, then you should be able to specify it, hopefully in the future, using the same framework from the European standard, the 14023 standard. So there is a pathway to specifying them and making them business as usual. And with that, I'll hand over to Gordon, who's going to take you through some test results.
Thanks, Donna. I think I've taken control of the screen. So as Donna said, there was a lot of obviously test data that had to be generated, mainly in the laboratory, by taking some of these materials and making specimens or recovering the binder and doing binder testing. So if we start by looking at one of the first things that we were concerned about in terms of trying to benchmark, we've talked about the fact that we've got lots of, residual data in terms of material testing. But we were very concerned initially, can we compact this material? Can we actually get it laid in the road to the densities required? So this is a very simple way of doing it. This is a gyratory compacted specimen where we've looked at the compactability of that material by measuring the changes in density as a function of gyration. So it's been plotted there in terms of air voids. That's simply about taking the density and obviously dividing it by the maximum density, which we would have determined. And it's pleased to see that the control mixture actually sits pretty much bang in the middle between those two binder asphalt mixtures. And so straight away we were confident, these materials obviously have been used in the field trials, but they can be replicated in the laboratory. And we were happy that we were able to compact them to the same kind of standard that we would have for control materials. But that was really much the first stage. Obviously, there are a lot of other properties we were looking at. I'm only going to give you a very, very small snapshot of what we tested in the laboratory. But one of the things that we were very concerned or least interested in initially was how do these biogenic materials perform in terms of standard type distresses. And so we looked at this particular example, wheel tracking, so rutting resistance. We looked at it usually two wheel tracking devices or two wheel tracking procedures. This is the small device procedure. So relatively small specimens. It's a solid rubber wheel. It applies about 700 newtons load, and it is placed on a relatively small specimen. And the idea is then just to simulate that kind of rutting, that wheel tracking of that material with time. And we usually do the test in this particular example. You can see in the graph, it goes up to about 20,000 load cycles. And we are measuring that rut depth with time or with a function of the load cycles. Again, very pleasing to see those two biogenic materials, trial 1 and trial 2, produce asphalt mixtures that were very similar to the control. But probably more important than just having that similarity, when we looked at the test requirements in terms of PD 6691, and that wheel tracking slope, which is effectively the degree of change, if you like, of the rutting with load cycles. So almost like a pseudo viscosity type measurement, which obviously is very fundamental to permanent deformation and flow. Those three materials, so the two biobinder or two biogenic materials, as well as the control, met those requirements of a wheel tracking slope of less than 0.8. And I think the units are millimeters per 1,000 load cycles. So that's very encouraging. We also did look at a second set of results for the larger device. So these are much bigger specimens, much bigger slabs that are produced from the same material taken from sites, from the plant. The test is slightly different. It's obviously a bigger specimen. It uses a pneumatic tire rather than a solid rubber tire. It applies, obviously, as you can imagine, a much higher load because it's a bigger wheel, but the contact stress is very similar to what we find for the two tests. And here we are looking at a much higher number of load cycles. So the test runs up to 30,000 passes. Both the small device and the large device will run at a relatively high temperature. So we're really trying to torture these materials. So both tests were done at 60. The results are slightly different, but if you look at them in detail, I wouldn't think that you're going to be too worried, especially if you look at the requirements in terms of the proportional rut depth, which is effectively just the rut depth divided by the thickness of your asphalt specimen, the slab. And they all met the requirements as found in the various BS standards. This is obviously for an asphaltic concrete type material. If we move on into the next slide, one of the key things that we were trying to assess is long-term performance, which means durability. And we know how detrimental water or moisture can be once it's in an asphalt mixture inside the pavement. And so this is the water sensitivity test using the indirect tensile strength ratio. Again, there are a number of different ways to look at water sensitivity, but this is a relatively quick and easy way of doing it. This was done by using the BS standard, where we have two groups or two sets of samples, small cores or cylindrical samples, if we make them in the laboratory. And we are looking at the indirect tensile strength of the dry set of samples and then conditioning the second set, the wet set, using different protocols. This is a relatively straightforward protocol, simple water soaking in a water bath at an elevated temperature, and then repeating that indirect tensile strength. And you can see the results are very encouraging. All three of them are pretty much almost 100% in terms of their strength ratio. Again, it's important to put this into perspective. Obviously, we need to make sure that although the results look very good, are they meeting the requirements in terms of these materials? And so we looked at the various clauses in terms of 942 materials and looked at what we would require for these materials as part of the EN 13108. And that looks at having at least 70% retained strength. And so we are well above that in terms of all three of those materials, the control, modified binder, as well as the two biogenic materials. So that was the first study, which, as Donna has mentioned, was relatively simple. There was no stack technology. We were simply looking at biogenic binders in the material relative to a control modified binder. But as Donna mentioned, what we were very keen to do to see if we could stack technologies. And so this second trial, the A2 in Kingston, was looking not just at using a bio-based binder, but also looking at a proportion of reclaimed asphalt or wrap material, and also a warm mix additive. So three different technologies that potentially should have a decarbonizing effect on our materials. And that's just the picture of the site going down. Material went down without a problem. It looked good. We again took material from the back of the plant, the back of the paver, and then did a laboratory study. So if we move on quickly, I'm only going to give you one or two quick examples of what we saw. For some reason that hasn't loaded. Just go back. Right, for some reason the actual lines haven't come up on that particular chart, but I can quickly talk to that through with you. This was the small wheel device, and there was the slightly smaller one, solid rubber wheel. We looked at three materials relative to the control. So the control had no wrap in it. It didn't have a biogenic binder, but it did have the warm mix additive. And so we had the control. We had two materials that were relatively comparable in terms of both having a warm mix additive. One had no % wrap and the biogenic binder. One had 20% wrap and obviously the biogenic binder. And then we looked at a third material, which was a hot produced material, so no warm mix additive, and again having the biogenic material, and again no wrap. So unfortunately you can't see the results, but the results, you're going to have to trust me, were very comparable in terms of the warm mix materials. The hot material tended to be slightly different, but we would expect that anyway. So if we go on to the next set of data, I haven't talked about stiffness yet, but obviously stiffness was a key parameter that we were looking at. This is again those four mixtures, the control, which had 0% wrap, but a warm mix additive, and then the three biogenic materials and asphalt mixture combinations. You can see the results. If you look at mixtures 1, 2, and 3, they are pretty comparable. As you would expect, there is a slight reduction it's a slight increase if you get to material 4, which is the wrap material, and that ended up being slightly higher in terms of stiffness. But in terms of the overall range, it is fairly comparable. We were happy that we were seeing ballpark figures that were roughly in the same area. The bottom table is the indirect tensile strength ratio. Again, we talked about that in terms of the A30. So for this particular site, for the A2, again, we're having our four materials. And once again, the results are pretty impressive in terms of their comparisons among itself, but also in terms of their actual values. There is a slight dip in terms of the strength ratio down to about 93%, so still well within the requirements of those materials for the material having the 20% wrap. I'm going to finish just very quickly by looking at some of the binders. So we were very interested in trying to get a feel for what biogenic binders do in terms of their rheological profile. And so these materials were provided for us. They were subjected to testing in the laboratory. So this particular graph, for those of you who haven't seen a black space diagram, is taking fundamental rheological data, so not pen and softening point, but data generated from a dynamic areometer. And we are plotting it in terms of two of its main parameters, the complex modulus, which in very simple terms is a stiffness, against a phase angle on the horizontal axis, which is a measure, if you like, of the viscoelastic behavior or balance of the material. So if you had a phase angle of 0, it'd be purely elastic. Phase angle of 90 will be purely viscous. So it's a balance between visco and elastic response. Ignoring the black curve first, if you look at the three curves, the purple, the bluish one, and the green one, those are the control and the two biogenic binders. They are very similar. That unique kind of transition to lower phase angles as you get to higher temperatures is very significant. It's one of the factors that you have for polymer modified binders, and it's nice to see that the two biogenic binders have exactly the same kind of fingerprint or profile. We've included the black one, which is a wrap binder, just to give you a comparison between an unmodified material in this particular case that has obviously gone through quite a large degree of aging. We also, as I mentioned earlier on, recovered the binder from these asphalt mixtures. So this is not virgin binder. These are binders that have been recovered, that have gone through and have been produced in terms of the 4 mixtures on the A2. On the left-hand graph, we've got effectively a stiffness plot. It's complex modulus against frequency. So the tests are done at a range of different temperatures and frequencies to try to cover the operational modes that you would experience with these materials in the road. And you can see that there are very similar behaviors for the 3, the control and the 2 biogenic materials. As you would expect, the material with the wrap tends to be harder. I think the results pretty much mimic what you saw with the stiffness results previously from the RTCY, RTSM. And then the graph on the right-hand side, just quickly to finish off on the material testing stuff. This is, again, those recovered binder. As I said, black space diagrams in very simple terms are like a fingerprint of the rheological profile of the binders. And again, our 3 materials, the control and the 2 biogenic materials with no wrap, are very similar. Slight difference, as you would expect if you add a wrap binder into the material. It does tend to change, particularly at low temperatures, or at high temperatures, where the modified binder is not as dominant in terms of its rheological output. So to finish off then, I've got a graph here of some of the LCA work, the carbon footprinting calculations work. This was data generated by the first 5 modules of the LCA process, so A1 to A5. So for those of you who know, A1 to A3 is the production of the material, and A4 and A5 to do with the placement or the construction of the material. So this is a good example of not only what the biogenic material is doing, but also how stacking has worked. So on the left-hand side, we've got a PMB with no wrap, a warm process. And as we go to the right, we are trying to increase the potential means of reducing that carbon footprinting by having a wrap content of 10%, then increasing that wrap content to 50%, then adding our biogenic material, which has no wrap and is actually a hot process, and even that still gives you a nice carbon reduction, making it more carbon beneficial by having a warm process with the same biogenic binder and 0% wrap. And then the last 2, trying to really push those boundaries by having 20% and 30% wrap. So you get a feel for what is possible in terms of that stacking technology, but also what the biogenic binder is doing in the mixture. So with that, I think those are my slides. I'm going to hopefully finish that presentation. And I don't know whether you want me to stop sharing, Malcolm. Yeah.
No, that's fine. Somebody else will take control behind the scenes there. Yeah, thanks for that. Some really interesting data there, particularly the stacking at the end, seeing where you can gain most benefit from which approach. So we'll have a bit of a discussion to come on, but I'll bring in a couple of other folk looking more at the local authority application. Obviously, those trials for national highways. So we've got Bill Larner, who's principal engineer from Lancashire County Council. He's got over 40 years experience in highways and construction materials, mainly with local authority technical service, and has done support for clients with pavement design, road trials, testing, approval materials, and delivering acceptance standards. And he's chair of the Northwest Elcraig Materials Group and the Northwest Hawk Materials Group, and a member of the ADET Soils and Materials Group. So welcome, Bill. And Adrian Hadley from Heidelberg Materials. He's the head of technical for asphalt and aggregates at Heidelberg, and is responsible for quality and innovation throughout HMEK asphalt and aggregate supply chain, including recycled and surfacing. Heidelberg are PAS 2080 certified and work with their clients such as National Highways and local authorities on sustainable solutions, and have also supported National Highways and Atkins with some of their trial materials, as Donna pointed out. So welcome, Bill and Adrian. Bit of an open question for either of you. Based on the sort of numbers and experience you've seen there from those National Highways trials, does that reflect your experience on work you've done on other networks? We'll probably start with Bill, actually, and your experience in Lancashire.
Yeah, it does, Malcolm. I think that we've done smaller scale local trials, and we've done a pretty large trial on the motorway network. We've followed the line that Gordon mentioned about performance testing. Our approach has been to try to have a biobinder that does belong to the actual bitumen itself initially, and we have done other trials with other components. But in terms of the biobinder and the performance to date on the trials that we've done, after 2 years of monitoring, they've stayed up very well. So they've exceeded the normal maintenance period of 2 years and are performing quite well. But we have always asked for compliance testing in accordance with the available standards, including the bitumen standard, and that's something that we've shared with Elcrigg colleagues recently, BSEN 14023, the importance of compliance and durability in conjunction with the carbon reduction. But so far so good, and we are intending to do more as we move on. It's a work in progress, but so far so good.
Right. And have you done carbon assessments as well to see those benefits?
Yeah, we have. Basically, it comes under our sort of carbon management strategy, really, where we do have a palette and matrix of materials that we permit for revise the palette and matrix of materials regularly to make sure that we've got the latest technology and so on. But within that, we also have a specification clause for contractors to provide us with EPD carbon information on materials. And from that, we're able to compile a carbon database of estimated carbon content of mixtures, A1, A3, A4, some A5 as well. And that is a work in progress also. And we're also building into that surface treatments for preventive maintenance. So overall, there's the carbon calculation aspect of our network that we do annually, and the individual trials initially are treated individually, but there's the potential to build data into bigger database.
Great, good approach. It sounds like. Adrian, from the producer's perspective, does this experience ring true?
Yes, Malcolm, absolutely. Some of our early trials were carried out with Dorset County Council, and we tried some different material approach, sort of single layer applications. They work very, very well, and somebody with Dorset, they were very keen to see the carbon reduction data initially through aspects and sort of further and more of the life cycle assessment data in terms of carbon reduction. And those sites are standing up very, very well, and from a lane and manufacturing perspective, quite interesting. The guys on site that were laying said the product handled very, very well. I think an interesting takeaway, some of the comments back were that you had a slightly different odor, and quite often reports odorless. So I think in terms of sort of safety aspect that we'll talk about in terms of reducing fuming, reducing emissions, there's some very interesting comments there received from the surfacing guys. So yeah, overall, I would absolutely agree with Bill's comments that similar approach to carbon numbers are stacking up well. I think it's safe to say as well, the sites where we have supplied over a number of years now, they're all performing very, very well, which is really encouraging. I think supports the data from Gordon and Donna in terms of test data.
Good, that's really good to hear that. I think on odor is interesting because particularly operational gangs, they may not notice an odor, but they'll notice a change. So as we're introducing new components, new products, new materials, it's the change that triggers people, and it's the change that people fear the most. I think that's my personal perspective. We've got a couple of interesting questions coming through, starting primarily on the recycling end of things. So one again there from Greg. Does the use of biogenic and PMB in surface course have any implications or limitations for future maintenance and reuse of asphalt, i.e. in the wrap that would come out of them? Now, I think Kevin Gilbert has slightly answered that, but he raises the sort of linked question, literally, would the binder from RA in bio-based binders still enable cross-linking with PMBs in fresh PMB in your future asphalt mixture? So I'll fire that to Gordon and Donna first, because you seem to have the first data, and Adrian and Bill have a thought.
Yeah. Gordon, do you want to go first, or I can talk about there was a big study done in France, the biorepavation study, that looked at exactly this and looked at multiple recycling cycles with that incorporated bio-based binders, and no there was no evidence that it wasn't suitable for multiple recycling cycles, if that makes sense.
Yeah, and Donna's right. I mean, that study was obviously quite an important one, but we've also done internal studies, not as part of the detailed SPATS program or National Highways SPATS program. And there isn't any evidence of what we've found that indicates that it doesn't allow for you to go through multiple recycling applications in terms of the material.
Adrian, have you had any experience with recycling what you've just recently laid?
Yeah, I think in terms of core samples that we've taken away, and let's obviously recovered softening point data, I think certainly softening points are a really good indicator in terms of polymer content. And when we have looked at it, particularly over the years, in terms of recovered pen on PMB, the numbers have been good. They've not certainly indicate any particular drop off or any deterioration. Some kind of aligned again with Donna and Gordon on that one in terms of that early initial research that we carried out. That I would agree that I've not particularly seen any deterioration or drop off when it comes to that recyclability of a PMB, or furthermore, one that actually contains a bio element.
I agree with that. I think that the changes to PD 6691 allow increased wrap content in lower layers and upper layers. There's no evidence to contradict that it will not perform based on the type of testing that was discussed by Gordon and Donna. So again, there's no evidence to contradict that. That's my opinion from what I've seen.
That's great. Right. I'll draw this. We're slightly over, so I'll draw the session to a close. There was one question there about cost. As an independent organisation, we can't address cost, but I think Ian flagged up right at the very start that yes, innovation and clever things will cost more up front. It's ensuring that we get the long-term benefits that comes with that cost. So we're not saying how much per tonne, but yeah, obviously it's part of the equation in whole life cost. So we'll take a comfort break for a couple of moments. I just want to recognise sort of where we came in, talking about alarm and support for alarm from bodies. I just wanted to recognise someone that spoke at our conference in 2007, Quentin Wilson, who sadly passed at the weekend. He wasn't someone that came in, took his fee and ran away. He actually continued to support alarm with media messaging for a couple of years afterwards. He was interviewed by various channels and put his personal opinion with our data. So that was when we were really starting to get media coverage for alarm. So my thanks go to him, and rest in peace and thoughts for the family. Okay, my colleagues will blast off at me now for doing that, but there we go. Right, so we were scheduled to come back at 11:35. I've got just coming 11:30 on my clock. If we say 7 minutes rather than 5, is that okay, David?
Actually, I think we've got one more session before we go to the break, so please don't rush off for your coffee.
Absolutely right.
Yeah, I think it was it was maybe not made clear to you. Apologies. So we have one more session, which I'll let you tee up, Malcolm, if you'd like to, or I can do it.
No, you're fine, David. Sorry, I misread my spreadsheet. There was a break in the list, and I took that as the break. Right. So, looking at the knowledge and data that we've just seen as an example, I think it's really important that authorities have access to data like that. And hopefully a number in the audience will be aware of the Adept Live Labs 2 project. So in relation to that, we've got Lauren Sablonka, and she's Innovation Business Partner at AMI and Program Manager for the Live Lab, leading the delivery and overall program management. And we've also got Scott Walker, who's the Roads and Asset Services Manager at North Lanarkshire Council and Senior Responsible Officer for the Live Lab, steering strategic direction and delivery of the project. So we'll give Lauren and Scott an opportunity to flag up how the Live Labs have been proceeding and how authorities can get access to data. Thanks both.
Thanks, Malcolm, and good morning all. Thanks for the opportunity to present the latest development in our Live Labs 2 project this morning, which is our recently released Materials Knowledge Bank. So just getting the contractual bit of the way first, Adept Live Labs 2 is a 3-year, £30 million UK-wide programme funded by the Department for Transport. It will run until March 2026 with a further 5-year extended monitoring and evaluation period. So Adept awarded funding for 7 projects grouped by 4 interconnected teams, all being led by local authorities working alongside commercial and academic partners, and North Lanarkshire Council and Transport for West Midlands co-lead the UK Centre of Excellence theme. So between us, we've got about £8.5 million, which is a substantial budget and an opportunity to make a difference. So why a Centre of Excellence? Sorry, is our slides getting shared? Does anyone see slides? No.
If you have slides, you need to click on the take control button up top left, Scott.
Yeah, I'm sorry, I'm attempting to press the button, but it's not doing anything.
I'll have to leave that in the hands of those behind the screen. I can't help, I'm afraid.
Okay. So I'll continue anyway. So why a Centre of Excellence? So all authorities face the same challenges, and hence our bid was to develop a resource that will provide the opportunity to share knowledge and tools across the whole the UK. It seeks to serve as a centralised hub for collaboration, so harnessing the collective power of our industry and sector. There we go. So on the second slide, I think, Lauren, please. She can get that. And the next one. Yeah. So innovation faces barriers such as specifications, lack of standards, organisational resistance, and procurement. So through the COE, we strive to provide a blueprint and tools to overcome these obstacles. We're seeking to reduce siloed working through the provision of an industry-trusted knowledge bank, which is what we're here to show today, where we can share best practice and learnings. Live Labs funding has provided the opportunity to trial the most promising innovative materials from across the globe and live scenarios where we would not normally take the risks due to the limited budgets that we've got as local authorities. So we've been undertaking an in-situ testing of the most promising materials we've found, backed up by academic evaluation, and we hope to share the results across the UK sector. So next slide, please, Lauren. So in terms of our journey so far, year one was focused on setting up the governance, our partner model, and identifying innovations. So we've got an extensive network feeding into our centre, including Nottingham and Aston universities for materials expertise and testing. We've got the FHRG, the Future Highways Research Group, for carbon accounting expertise. And we've got expert panels, including reps from across the country in Transport Scotland, National Highways and Senior Highways engineers from across the UK. Year two was when the live trials commenced. So over the last 18 months or so, we've undertaken around over 40 trials of low carbon materials, and we've got a number of other key work streams in progress, including examining behaviour change across all levels within highways authorities and within the workforce hierarchy. We've got an innovation sandbox, which seeks to understand the blockers to scaling innovations from an SME perspective, and we're also developing whole life carbon accounting tools and for materials, and that's been a key challenge which we're still working on with FHRG. So I'll now pass you over to Lauren, who will go into the knowledge bank in a bit more detail.
Great, thank you, Scott. So as Scott alluded to, one of the key challenges we're also looking at is behavioural change, or how we support knowledge sharing, ultimately to build confidence in local authorities to adopt some of these new or different materials that offer carbon savings. So one of the main methods that we have developed over the last few months has been an online open source knowledge bank to support local authorities to identify and also share their own case studies and best practice in decarbonisation of materials. This has started with initially behavioural research, so working with 10 local authorities across the country. We identified our end user requirements and also their behavioural barriers. So what information, features, functions would really enable them to use this tool, first of all, for it to be useful to them, but also to ultimately adopt those materials. We then went into wireframing, sense checking that with our local authorities as well, and an IT options appraisal and onboarding. And then most importantly, over the last few months, working on the design and development of the tool. So again, working through focus groups with local authorities and also suppliers, doing our initial UAT testing, and now we have launched the tool itself. So just a quick view of what that actually looks like. And as I mentioned, the intention of the knowledge bank really is to be something that is a repository for the sector's knowledge. So we have developed and put in the options that we have identified through our live lab. And this is very much a work in progress. So we're continually adding and inputting what we've looked at to date, but also we want to hear from the sector. So looking at both an evidence base for local authority case studies, having a standardized form and a map where you can actually filter by material. For example, if you do want to look at biogenic binders, seeing where they've been trialed elsewhere in the UK, having a peer review feature, so actually local authorities can leave their thoughts on their operational or experience with those specific materials, and really just to support that wider peer-to-peer collaboration that does happen often, whether it be in pockets or at an event or a conference or at a webinar even, but how do we store that long term and make sure we're building on, so to speak, the shoulders of giants. As we talked about, it's not a finished item. This is very much a framework for hopefully exchanging our knowledge. So we need the input from other local authorities. We need case studies. We need other materials maybe that you've identified that we haven't yet identified. So as much as possible, we're really inviting the sector as a call to arms to support us. As I mentioned, there are some more steps in the process. So we've done our launch. We did an initial webinar, which you can watch back. It's on our YouTube channel. We've also done some demos at Highways UK, and we'll be at Road Expo in Scotland later on this month. And we're also looking at, as I mentioned, continually inputting the data, the reports that we have, for example, from our work with Nottingham, as and when they come out, and publishing those as well. We're working on iterative development, so this is very much sort of a beta phase, and we're looking at collecting as much feedback from the sector as possible over the next few months. And we're already working with our developers to make edits. So we've already looked at tweaking the review feature, for example, and ensuring that we're keeping that up to date. And then when we do these edits, we'll do regular re-releases, let you know, and you can follow us on our LinkedIn or subscribe to our newsletter, and we'll be pushing out which updates and edits we've done within that period. But we're looking at, for example, how we interlay AI, creating a local authority forum feature as well, supporting sort of supplier and local authority discussions within the reviews feature, and also working with our technical leads on some specification guidance and how we present that on the knowledge bank. So we're a little bit limited on our time within this session, but I will invite all of you to visit the knowledge bank. You can access it via this QR code, or if you go to our website, decarbonisingroads.co.uk, we have a big button at the top, but you can also access via this link as well. So please do feel free to both look around, leave your feedback. Keep in mind that it is a work in progress, and we want that those recommendations, those suggestions, because this is a tool ultimately for local authorities, for the sector. We want it to be shaped by you. So please do let us know what you would want to see differently in the next re-releases. And as well, if you do have specific feedback, we also have a Mentimeter that you can access on this QR code here. And we welcome any inputs from that perspective. So please do leave your thoughts. And if you do have any questions, reach out to myself or Scott, or to our wider team at the West Midlands and Colas down south. And we'll hopefully see many of your inputs on the knowledge bank soon. Thank you.
Great. Thanks for that, guys. I know we didn't give you an awful lot of time, but definitely felt it was an opportunity to show how others can share best practice and current experience. So I've corrected myself. Ironically, I pointed out an error in the program last night to colleagues, and I made an error myself. So comfort break from now. If we can come back as close to 11:45, 11:45 as possible, please.
Okay, thank you. Welcome back, everybody. So we've looked at a number of different innovations already. Now we're going to move on to increasing use of recycled asphalt. Westminster City Council, its contractors laid new road surface containing 92% recycled materials, which is the highest recycled content used anywhere in the UK. And to talk about this, I'm going to bring onto the screen Mark O'Leary, who is the operations manager at Westminster City Council, who led the project, Ivan Farrell, who is a performance manager, and Mark Flint, technical director, both from FM Conway, to talk about the screen. So welcome on board, everybody. Just a reminder, your presentation will take just a couple of seconds to load up. And then once it's done, please hit that little take control icon at the top of your screen, and that'll allow you to navigate. And for everyone who's in attendance, please don't forget, pop your questions into that Q&A, and we'll bring those up at the end. So I'm going to hand over to the two Marks and Ivan.
Thank you, Ian, and good morning, everybody. Let me just take control of the screen. Yeah, I'm Mark O'Leary, Operations Manager at Westminster City Council, and today we'll be sharing how we're driving improvements across our network to make our works more sustainable. At Westminster, our role is clear. We're responsible for maintaining a safe and well-managed road network for the residents and visitors to the borough. So if London's a wheel, then Westminster is definitely at the hub of that wheel. And that means we need to ensure that our roads are lasting longer, we reduce defects, and we deliver works in a way that's both efficient and environmentally responsible. We're not just maintaining roads, we're shaping a network that supports Westminster's climate commitment and the future resilience. So just moving on, our main drivers are all about quality, sustainability, and collaboration. First, we want a safe and well-managed network with fewer defects and longer life roads. To achieve that, we very much take a data-led approach, where we use our highways maintenance and management system to analyze defects and apply a bespoke value management process that's very much led by our inspectors team, or our inspection team, sorry. So we aim to try and get a consistent approach across all work streams for reactive works, planned maintenance, and preventative resurfacing, and all the time maintaining that sort of close relationship with other departments and third parties. Collaboration is key to the way we work with FM Conway and other partners. We want to trial new materials and improve the durability, and sort of meet our climate resilience goals wherever possible. This ties into our 5 Cs, if you like. So the commitment to tackling the climate emergency, reducing our carbon output by 50% by 2030. That's based on a baseline level that we took in 2022-23. We're looking at continual improvement for innovation and for better results generally in the performance of our network. We want to challenge existing specs and sort of common held beliefs in materials. So we've looked at low carbon specs for footways, carriageways, and developed a surfacing matrix that helps us towards those goals. And last but not least is coordination and engaging with stakeholders, taking our residents and groups and politicians on that journey with us. So we're engaging internally and externally to sort of achieve those best outcomes, and very much that sort of taking people with us, with good coordination and communication. So on that note, I'll hand over to Ivan Farrell, Performance Manager at FM Conway, to talk through the next couple of slides.
Morning, everyone. Thanks, Mark. Yeah, so as mentioned, I'm the performance manager on the contract, and pretty much that role means that I collaborate very closely with Mark and the team in how we can improve what we do and get some of those carbon savings and some of those additional RAP benefits, and just all around making the performance of the contract better. I think the first thing to mention is the 92% RAP scheme mentioned at the beginning on Elmfield Way doesn't just come about by accident. It's sort of taken many years of planning, of monitoring, and also sort of several years of incremental improvements using those stackable technologies, adding everything together and just taking a holistic approach to how we treat the network. So I suppose the starting point is that traditionally the specification on highways in Westminster has been hot roll and chips. Very good material, nothing wrong with it. It's got some limitations, particularly around rutting, but it also, in reality, is an over-specification in a number of areas, particularly where we've got slow moving traffic. You don't quite need the skid resistance that it gives us. Now, this kind of first came to my attention way back in around about 2017. One of the highways inspectors approached me, quite nervous because one of the roads on the Notting Hill Carnival route, a bus stop there, was showing severe signs of rutting. So obviously I went to go and look at it with him, and it's obvious straight away. It's Chepstow Road, for any of you that might know the area. There are parked cars, and there is no way that two buses can pass each other. So the net result of that is that the buses spend a lot longer than they need to sat at bus stops, running the engine, heating up the carriageway, and eventually causing the longitudinal depressions. And at that time, because we were a little bit hamstrung by the specification, the inspector had no choice but to say, look, we need to put this back into hot roll. I went back away and did some further investigation and looked at some of the outstanding defects that were on the network. And this actually was a recurring theme right the way across the city. So this really then became sort of our first step into reviewing the service. We'd had the contract for about 3 or 4 years at that stage. So we arranged a collaboration workshop with Mark and the Westminster team, and also Mark Flint there and all the technical guys. And it was really to plan a way forward for how are we going to be more proactive on the network than just reacting to where we find problems. So we looked at some of the newer material choices that are out there, and particularly some of the other innovations, such as what was going on in PMBs. Very successful meeting. Everybody was fully on board, trying to make those continual improvements that Mark touched on there earlier. And what we did, we took some of those problem bus stops and we trialled the material. At the time it was called SureStop, a lot more durable, hard wearing, and we put them into a number of bus stops, monitored their performance, see how they were going on, and they performed markedly better than some of the HRA ones that we'd had previously. So straight away we had the confidence that we could challenge the specification, and we didn't just have to stick to the HRA, but we could make things better. We could make things last longer out there for everybody. Not long after this, we came across another incident on Bayswater Road. Some of you may know that's a main strategic road that takes you into Oxford Street and Park Lane from West London. Now, the issue we had there was we were in need of doing some maintenance work, but it was difficult getting the road space. So essentially, it needed a full closure to do the works, and obviously with the road being tied in with Hyde Park on one side, that made diversions very long, and the powers that be were a bit reticent to give us the road space. So we looked at some of the other materials that Mark had available at the time, and there is a material called Shore Layer, which is a single layer treatment. It doesn't require a chipping machine. And essentially what that meant was we could get away with doing the works under directional closures, so we weren't clogging up the network, but also because it was a single layer treatment, it meant that we were off the network quicker, and also the material itself automatically would come with 50% recycled content on it. So that there was a number of different benefits to trialing that. So again, we monitored the results of those, and we were confident that in some of the other areas in the borough, it might surprise you to know that actually you might think of Westminster as being the Houses of Parliament and Trafalgar Square, but actually around about 87% of the network is either residential or mixed use, and sort of lends itself to that single layer treatment. We looked at a road in the north of the borough, and we started to think about, well, okay, can we challenge what we've done already? How can we improve on what we're doing? We found a road on network called Sutherland Avenue, and what we did there, we tested the 50% normal treatment against a new 80% wrap treatment, and we put one in one lane of the road and 50% in the other, and we monitored how that went. We got some independent researchers to come and do a full report and found that the quality of the materials matched, and indeed visibility wise exactly the same. You would never know the difference. We used to have a bit of fun taking people to site and ask them to guess which was which, and no one could really tell the difference. So after sort of about a year of monitoring, we were making sure that there were no failures, that this was working properly. We then looked to see, well, what else is it that we can do to try and improve on this? And we felt that using wrap and actually making those savings was the right way to go about. And this coincided with the advent of the climate emergency and the targets that Mark spoke about, trying to start reducing the carbon impact in everything that we do. So we started looking at other treatments such as warm mix. There was another street not too far from Sutherland Avenue called 3rd Avenue. And in that, Mark Flint approached me and said, look, we're starting to use warm mix is out there. Is there somewhere we can trial this? So on our PPM program, that's our plant preventative maintenance program, we started looking at areas where we could try some more of this new material, monitor it, see how it works, so we can bring those benefits to the rest of the network. Also, I challenged him then, okay, well, can we increase the wrap that we put in at the same time? The results were we managed to get an 85% wrap at that time using the warm mix, and a number of benefits came out of the back of that. That then gave us the confidence to actually look at the programme as a whole, looking at all the different streets that we've got under our value management process in selecting schemes for the year. We found that roughly about 50% of the schemes on our programme we could probably undertake with the short layer material. Following sort of the Sutherland Avenue and 3rd Avenue, it was agreed, well, let's try and actually do the whole programme. Let's see what savings in the carbon field that we can make out of that. Huge savings made. If you think there's around about 50 odd schemes a year, I think we were saving around 100 tonnes of carbon on that. But we wanted to go further. We wanted to see what is the art of the possible. We found a street on the network that used to be owned by the NHS but was being adopted by Westminster. And we saw that as an opportunity to actually really use that as a test bed. How can we bring that up to Westminster standards? Mark Flint then took that away as a mission, looked to see how we could store enough recycled material and what could we achieve. So we worked on everything as a holistic approach, and I'll show you some of the results about that sort of in a minute. But the net effect was we managed to save around about 92% of wrap within that scheme, which is a record as far and not been matched as far as we are aware. Do you want to pop on the next one, Mark? So a lot of what we've been talking about in terms of carbon savings is not just putting wrap into every scheme we do, but actually thinking about what goes into what street. So for us, the biggest carbon saving is in actual fact improving the durability of the road. So if you can improve its lifespan, that's the best carbon story that we can come up with. And by challenging that specification, we started looking at what were the road characteristics, what sort of traffic is it taking, is it a bus route? And we started to develop some different mixes for the different types of road types out on the network. Again, using those innovations in there, using more PMBs, making recycled content one of our main priorities. But again, we were very careful to understand that there would be certain roads where this particular treatment wouldn't work. And it wasn't in anybody's interest to just start putting wrapping into every street, but more using it as a targeted approach. So, for example, on some of our major routes, such as Piccadilly and Whitehall and Shaftesbury Avenue, we've actually developed a newer material now called Shaw Lane, which is almost like a derivative of the bus stop treatment that we spoke about earlier. And Mark Flint has done an awful lot of work on airfield specs. So we use a lot of that technology in that as well, and it's a lot more durable, hard-wearing material, less prone to rutting on some of those bus stops. So for us, it's about getting your bespoke matrix of materials and getting them into the right place at the right time to give you that better network out there. And again, other offshoots of this have been the move to 20 mile-an-hour networks has meant we don't really need to worry so much about sort of anti-skid as much, which can be quite expensive. So we're using very much a risk-based approach on if there are sort of no accidents at that location, can we look really just to use the new materials matrix that we are producing and using out on all our streets. I think, Mark, if you want to go on to the next one, I can just show you some of the benefits that we've got in terms of the approach that we've taken for the recycled material. So we've taken
this shows the stackable technologies, doesn't it?
This does indeed. Thank you, Mark. So essentially what you're looking at here are, by using all the various stackable technologies together, the carbon benefits that you can get by just thinking about the scheme holistically. So if you look at the sort of the left-hand side of the graph, if we'd have done the scheme there at Enfield Way in HRA and chips, you're looking at around about 33 tons of carbon dioxide equivalent. Now, as we move along the graph, by using the single layer treatment, that saves you around about a third of the carbon because you've got less material coming out, less material going back in. The recycled content gives you another massive saving because obviously you're not digging out virgin material and the transportation from various suppliers on that. And then sort of incrementally down, we got sort of some of the smaller changes that all add up. So the war mix technology, again, that's a bit better for us. Moving down, we have an electric crane down at our wharf at Gravesend where we unload all our bitumen and materials. So again, there's a small saving to be had on that. Logistical efficiencies, we always make sure that we are backhauling in terms of deliveries and then taking away spoil away from site, thinking about what we're doing, planning the works. And the big one for us logistically is that we have banned diesel from all of our sites. So where possible, we do electrify the plant, but as I'm sure many of you are aware, the larger plant now, the technology isn't quite there for us at the moment. So we use HVO biofuel, which gives sort of a 90% saving on carbon.
So, yeah, I mean, as a client, so just to talk about those stackable improvements and those incremental gains, some of those improvements are more expensive but have become less so over the course of time. So with the wider use of lots of these things, improved plant and HVO, the initial sort of innovation piece and change of specification was more expensive as a client, but with wider use those costs have come down.
Yeah, exactly, Mark. And we've also shared those costs as we go along. Looking into the future, again, technology isn't quite there for us at the moment, but but we believe sort of the next stage is going to be using those zero carbon electric or possibly even hydrogen plant and vehicles, and possibly even where can we improve actually the Ashvale plant itself in terms of how that's powered. So that just gives you an idea of just how you think about a scheme and the impact it can have on you. So in terms of the benefits to the client, I think, Mark, you're just going to lead into some slides now of what you've seen out there.
Yeah, thanks, Ivan. Thanks for that. So as the LA benefits for us are first and foremost more sustainable works, delivering those sort of tangible carbon savings and reducing the our environmental impact. Using that single layer treatment on some of our roads means sort of less time on site and less disruption. We're giving people back their parking spaces and bays in a quicker time. Also translates into cost savings. So if you think about a single layer treatment, less time on the network, potentially taking a whole shift of operatives and plant out of the equation, less vehicle movements also, so you're carting around less material, less pollution and less noise, and adding into those stackable things, it's sort of the warm mix technology helps to cut carbon even further. Ultimately, we are improving our network and minimizing disruption at the same time, and all the time, you know, wary that we want to reduce our environmental impact and give residents the streets back for use as soon as possible. So, you know, with our network management hat on, we're performing that duty at the same time. So yeah, from our perspective, the right material in the right place, and if we can use that single course treatment and it's in the right place, then the benefits are clear. And on that note, I'll hand over to Mark Flint to talk us through the next slide. Mark.
Okay, thanks, Mark. Good afternoon, everybody. Mark Flint, Technical Director. And I've just got two slides. One is to show you how things have developed, and the final slide is about the future and what the opportunities and challenges are as we move through what we're trying to achieve. The asphalt mix development, as has been pointed out by both gentlemen, it is a genesis of actually trying to find the right material for the right area. But we've gone back to basics. We've looked at materials that are in there, particularly EME2, and how we can develop that by using PMBs and then combining RAP in there, and moving on from cold mix additions of around about 20% up to and including 70%, and that then becoming the norm. And this has been aided by us having our UCAS laboratory up at Gravesend, where we can actually test these materials at length, gaining the data, which allows us then to go back to Westminster and say, look, we've actually got some materials now that we can actually start to trial out on site. We've got laboratory data to suggest that it will work in terms of durability and performance. But on the back of that, if we're using more RAP, then we've actually got to make sure that we're getting the right RAP. So we do significant coring, where we're looking for, firstly, is there tar, which we obviously don't want to include, but also looking at the condition of the binder in that RAP to see how we need to modify the mixes that we're going to make and what type and shape and size of aggregates in there, again, to ensure that we get a good homogeneous material that will perform. Once we've actually sourced the RAP and processed it, again, and these are lessons learned from the continent over the past 10-15 years, that RAP needs to be treated as a virgin type material. You've got to look after it. You've got to keep it dry. The worst thing you can do is allow a lot of water in there, storing it outside, because you'd end up spending a lot of energy by doing that, and the carbon you're trying to actually save, you're actually expending by superheating. Grouping the program, this was a bit of a challenge. And what we thought was, instead of doing different sites at different times, if we could group all of these sites together where we'd have a concerted run of high wrap materials, but we could also then leave the plant on site. So we weren't moving pavers, rollers, low loaders, everything else in and out, which is obviously less stress to the residents, less carbon in terms of the vehicle movements, and it makes life a lot easier. Once we've got that, then the only other option obviously was, we've got the 2 twin drum plants, one at Erith and one at Heathrow, and these are specifically designed to allow us to get up to these high percentages of wrap. We said we've got up to 92. I think there's still an ambition to get further. And again, we're that confident now that these materials are going to work in how they are, that we are now offering an extended warranty to Westminster, and this is borne out by the regular yearly checks that we perform ourselves with Westminster and FM Conway to assess it. And at the moment, certainly the roads that we've laid like this are not showing signs of any distress at all, and are performing exactly how we'd want them to in terms of durability, performance. We're not getting the telltale signs of wheel tracking or fatigue type cracking, so we're quite confident, which is again why we offered that extended warranty. Next slide, please, Mark.
Thanks, Mark. I just want to say before we move on, the grouping of the programme is slightly more challenging in Westminster. So yeah, it's something that we aspire to, but it's not always achievable. And in terms of extended warranties and monitoring, yeah, the materials are performing and standing up to that scrutiny. But obviously we're suffering from utility intervention and emergency digs and all of the activity that happens in this sort of dynamic network is a challenge for us. But yeah, in terms of the work and the materials, they are performing. It's just a challenging environment to work in, as always. Thanks, Mark.
Thank you. As I said, the future, opportunities and challenges. The opportunities are that national specifications are now encouraging more use of wrap. Certainly in terms of Westminster, there was agreement between us and Westminster what we target. We're not going through routes of departure. It's a conversation about what we want to do, but I think in terms of certainly the UK, there definitely now seems to be more of a encouragement from local authorities, from national authorities, that wrap usage in a controlled way needs to become the norm. It shouldn't no longer be looked at as secondary material with bad press around it. The perception is that it's not as good as material that doesn't have wrap in there. I think what we've proven over the past X amount of years, not just within Westminster, with TfL and National Highways, is that wrap usage done in a proper way does work. And the higher quantities of wrap not only mean more, but the quality needs to remain as good as what it always is. And if there's an opportunity for people to produce and share wrap, I know we've looked at this industry-wise before, and there will come a time where this needs to happen. Challenges, and these are questions to everybody to think about. The availability of wrap material. Is it available where you need it, when you need it? Is it sustainable? Can it be used? If we have got the wrap, have we got adequate storage space in which to keep it, to protect it, for it to be used correctly? And the final one is the powering of asphalt plants. Are we moving into hydrogen soon? Will that be a quick, short step into electric? That's the question that remains. Thank you.
Thanks, Mark.
Thanks, guys. Really, really brilliant effort there, showing a lot of stuff on collaboration, forward thinking, maximizing the assets that we've got available. We are really, really pushed for time. So I'm just going to take just a couple of questions. One was, what's the maximum RAP percent that's been used in surface courses in Westminster? Is that the 95 that we were talking about?
It's the 92, wasn't it? Elmfield Way. So yeah. So far 92.
92.
Just on that, sorry, Ian, as well. Because of that, our default has now moved from 50% to 70% as well. So we are pushing the boundaries as business as usual.
Yeah. Okay. Cool.
I've mentioned that project Elmfield Way was carbon neutral as well. So we'd done some footway works with a low carbon spec, the carriageway with that high RAP content, and Conways took it upon themselves to make that a carbon neutral scheme by offsetting and offsetting some gold standard offset projects as well, rather than greenwashing.
Brilliant. Just one. The final question: what do you do to enable workability when you're working at such high RAP contents?
It's using warm mix additives, Ian, making sure we've got a good grading, that the binder content is right, and then using the warm mix additive as it was originally developed for workability.
Excellent. Thank you, guys. Really good contributions there. I'm now going to hand over to Simon Wilson, who's the Research Programme Director for the Future Highways Research Group, FHRG, who've done a 4-year carbon research programme culminating in a carbon leadership programme, national audit of carbon baselines and assessment best practices, adoption by highways authorities. So Simon, if we'll just bring your slides onto screen, they're arriving now. If I can just ask you to take control at the top of the screen, and it's over to you.
Very much. So I just thought I'd brief you folks on the Carbon Leadership Programme. As I say, it's been up and running since late May. We're now getting returns in, but I'll give you a full briefing on what it is and where we're going with it all. So purposes and goals. This is a DFT funded, so it's free to all English authorities. A program of 2 parts. One is to try and get carbon footprints for as many local highways authorities to get a English signature of carbon outputs across all LHA. So 153 are invited to participate. We're also doing a second part of the study, which is to understand the degree of best practice that's being adopted in the sector. So this is a fairly light dive. It's only looking at 67 factors across 7 dimensions, and probably will be extended in future years. It's not mandated. You don't have to do it, but it is currently funded for you to do if you would like to be able to benchmark yourselves. So that is the scope of the program. Currently, we have 58 authorities who are completing their assessments. So that's cohorts 1 and 2 are full. Cohort 3 for the spring is, I think there are only 7 places left in that. But as I say, we'd love to have as many authorities on board as possible, and we think the data will be very, very interesting. So in terms of who's doing what, we've got ADEPT, our program managing it, DFT are funding it, and this has ministerial approval and support, as the letter that went out shows. We, as Proving Services who run the FHRG, are managing program delivery. We have FHRG members as peer reviewers who will be attending the meetings for each review with each authority, and Coalesce's carbon team have provided additional support for authorities who don't have the internal resources to gather the data. But to be honest, most partners are able to do that sort of stuff. So it's there should you need it. This has been a long journey for us as a research group. So we started with a sector review and something called CCAS, going back now 4 years. So we started with this as an entirely FHRG-led research program. We looked at the state of readiness in the sector, and we built some carbon accounting standards for highway services, which are available on the ADEPT website. We then worked with DFT to support the quantitative carbon guidance, which was released earlier this year. We've also been supporting Live Labs 2, and that all culminates in the CLP, which is the current program, which is now a DEP-led and DFT-led program. So I've mentioned QCG, and I promised DFT I would. So this is how this all glues together. So for those of you who've read QCG, there are 4 major streams, and we have built tools to support that and also dovetailed those tools into the CLP. So all of those tools are available to anybody who wants them. There's no fees for any of it. There's the Carbon Footprint Assessment Toolkit, Carbon Best Management Toolkit, and Carbon Profiler for authorities who want to take a look at different delivery options for processes or materials. We've preloaded that with all the CEDA data. So, and it's got 6,500 emission factors as well from all the common databases. So those tools are available to anybody if you would like to use them, and they all are designed to support not just the CLP, but also QCG. The toolkit itself, sorry, I've skipped a slide there. The process itself for the Carbon Leadership Programme, we have kept as brutally simple as we possibly can. We issue 2 pro formas, the Best Practice Assessment and the Carbon Footprint. That's done through an email exchange. We will then process your data. You don't have to worry about emission factors. In fact, there's very little to worry about at all. Just tell us how much you did. So how much resurfacing did you do? Provide your specifications. We will work out the emission factors for you. Now, there's good reason why we're not allowing authorities to put their own emission factors on. We don't know where those emission factors have come from, and we're not sure we believe them. So we have worked to get an agreed set of emission factors that we are prepared to use for every highways function and for every activity. When you get your completed workbook back during this process, you will have additional columns with the emission factors we've used, and you are free to enter your own if they are more representative and you have the evidence to believe that those are good, and then you can calculate something that isn't using generic emission factors. So the process is we take it, we collect your data, we run the reports, we then schedule a workshop with the senior leadership team of each highways authority. We review the carbon footprint best practice, we understand what you're doing to improve your future carbon position, and then finally we enter that into the benchmarks database, and we're reporting biannually to DFT. And for all members who participate, you will be able to benchmark your position against the anonymous data sets of every other authority that look like you. So similar network lengths, similar budgets, similar spread of functions and activities. So I mentioned that there were 2 components to this. As I say, we've kept this so that we send self-assessment pro formas out. You return us your completed assessments. We are providing training for each of the authorities. Part of this is to try to get the competence client side. There is a significant demand for having this as a permanent process. So all the tools, as I mentioned, are free. Participation is free. It's entirely up to you whether you want to play, but all the tools will be provided for you if you want to run it year on year. And you have the option of third-party support if you want to do it either through your provider or through COLAS, who we've been working with on some of these projects. The pro forma is really, really straightforward. It's broken into a number of dimensions. So we've got carbon overheads, which are your classic scope 1 and 2s, maintenance activities, street lighting, which allows you to break out your street lighting schemes, resurfacing schemes, which allows you to specify surface, binder, base, and curbing and ironwork reinstatements and distances from asphalt plants, all of the good stuff. All of those things then you can specify, you can roll them together if you've got a similar specification over multiple schemes. We just need the headline number. So once those are returned, then we can process that for you. The best practice assessments uses a normalized tree weighted scorecard. So that's broken into a number of dimensions. Each dimension has a factor. That factor is described in detail in another tab in this comprehensive scoring guidance, and it gives you a range from poor to excellent. Just select the one that best describes you. That goes in your performance score. Confidence is how much do you believe your answer? And the final one is opportunity for improvement, which is how much do you believe you could improve that score in the future? So these are very simple, no automation workbooks. We wanted them to be accessible to everybody. All the heavy lifting is done at the back end. The tools that we send you will be very heavily automated and web enabled to be able to connect to central databases. But for the pro formas, it's all really simple. And on that theme of keeping it simple, we have fixed the boundary. So what we've looked at from the earlier research is where 80% of the emissions come from, and they come from this boundary. Now, we know this boundary is not comprehensive, but this is where we're going to go shopping for the emissions first. So we've got, as you can see, it broken out in this simple little tree, what we're looking for from each authority. If you don't do some of those, you don't have to reply on them, but for all authorities, we're trying to get that map. Again, I've mentioned emission factors. You don't have to worry about them. We've worried about them for you. So for the CLP, we've used emission factors from multiple sources. We have commissioned our own research around emission factors, and we've used some EPDs and averaged EPDs. The problem with EPDs is that actually some of them we have discovered are not really as accurate as we would like. So we've had to qualify some of that. So you don't need to apply those. We will apply general ones. You can apply your own later. And my screen has just gone black. How about that? Sorry, folks. I have no idea.
Can you no longer see the presentation, Simon?
I can no longer see anything. Right. I'm back.
Cool. You're back. Okay, good.
Excellent. Thanks for that. Right. I couldn't see what was going on. So let me go to CLP reports. These are some indication reports for you to take a look at. The first one is best practice carbon analysis and benchmarking. Just as a very simple thing, here are the 7 dimensions with all the various sub-factors within them. What we want you to be able to do is compare where you are with a basket of other authorities as benchmarks. So you can see in this particular case, we're better than the basket of benchmarks in how we work with our providers and staff and contractors and premises sites. Not so good in terms of our corporate policies and functions and activities. This is going to be really interesting because the political landscape has shifted dramatically on carbon. The other thing then, when we come to the quantitative stuff, is we can then see where all the carbon is across every function within an authority. And one of the really interesting things in this is how we have focused so much on one dimension as a sector, and actually it's not quite as important as we like to believe. So if we take a look at all of our material choices that we can make between the best and the worst that we found, actually it's only 3% of the carbon profile of the authority, of the Highways Authority. A huge amount of commissioned plan maintenance is staff, vehicles and plant. So there's this sudden realization that there's a lot that we can do in other areas, and we cannot keep blaming materials for our carbon profiles. And I was really interested in the last presentation because I think they touched on some realizations that we're probably late to the table, waiting for the data to see. But I'll revisit those. So you can see here, that's the spread of a current service. So when you add these things together, how much are we doing? We've got a very small sample at the moment. Forgive us, we're still buried in collating our data, but you can see the amount of CO2 against a BCPA score, the best practice performance score. We can see where the spread is. We can now see from the latest batch that we processed on Friday that the constellation is starting to group more meaningfully in terms of how we would anticipate this. The really counterintuitive thing is we think the average will go backwards. We have found a significant number of authorities who now see carbon as not being a priority. So the BCPA score we expect to fall. We're also expecting falling budgets. In fact, we're already witnessing falling budgets. So as authorities spend less, they produce less carbon. As they start to adopt fewer carbon sensitive policies, initiatives and programs, we are anticipating the BCPA score going backwards as well. Counterintuitive though it looks, actually there is some good news in that, but I'll return to that in a second. We think therefore, and what we're finding from this, which we think might be very much more interesting, is as the focus of carbon shifts politically, we can see that there is a new focus on classic business benefits within authorities, and this was echoed in the previous presentation. If you're just sorry, I'm skipping around. I'm going to go backwards and forwards here. If you're just really good at delivering classic business benefits within an authority, then like these, so these are some really solid business benefits, but use carbon as a constraint, you will start to get much more broad political support and carbon will continue to fall. So we're seeing this even in authorities which are very hostile to the carbon agenda, and after next May there may be many, many more of them. If you're able to reduce your costs or increase your performance or increase revenue for the authority, then if you can do that with a container as a constraint, a program constraint with carbon, you can continue to see carbon falling. There's a reason why there is a degree of hostility, which I will come to now. When we take a look at the carbon that we're getting from the samples that we've got, and I've excluded from this construction, because that's a very varied landscape across authorities, depending on the size of their major schemes, capital works programs, you get about 10,000 tonnes of CO2 from the sample that we've got so far. That's low, by the way, folks. That will go up. We're expecting some big returns, but I'll go with the data that we've got. Let's make a pessimistic adjustment for the restricted reporting boundary, errors and omissions, and the fact that we've used average emission factors and yours are likely to be better. So we'll make that about 12,500 tonnes of CO2. So it's, sorry, the distortion there should be 153, but with all of the reorganisations going on, we got a bad number. But that's 1.9 million tonnes of CO2. We've got then the share of territorial emissions is 0.5%, and the share of total emissions in 2022, which is the latest data that we have, is about 0.27%. So in the original research exercise, we got 0.24%, so we weren't a million miles out. If you then apply that globally, then it's nothing. It's in the errors. So that's the reason for the political shift that you've all experienced, and we're seeing it with the roundtables that we do with portfolio holders. But that number matters. That's a huge number. But what we're also seeing is almost certain climate change. So if that's coming come what may, again, harking back to the previous presentation, the resilience of the asset becomes the focus, and all politicians that we've interviewed are interested in that. Longevity, resilience, all of those things now become critically important, and they come with primary Treasury Class 1 cashable benefits. So the landscape is changing. Carbon moves to becoming a constraint. There's a refocus back on classical business benefits. I think that's a really, really good thing. I said that materials are being blamed for everything, and they are at the moment. So it's all about materials choices. Actually, as you saw in the last presentation, in situ and ex situ recycling will have a much more profound impact. By the way, that last scale of recycling I just totaled up what we got from the survey so far is the average in the UK is 18% RAP. So you guys are doing amazingly well. But there you go. So if you move to a use, the reduced use of virgin materials to recycled materials, that will have a much more profound effect on moving from hot mix to warm mix. It's a much bigger impact. But there are many other things that you could do that would profoundly change your carbon position, much more than choices of materials. And we're hoping that this takes some pressure off of materials, because it's had to carry a very heavy load for the sector. There are lots of other things, and I'll just draw on VFM improvements. If you are just good at running a highway service, you don't return to the jobs, the jobs don't fail, you're just really good at scheduling works, you will have a profoundly better carbon position than just trying to swap one material for another. I know that isn't counterintuitive. That is now supported. We run the VFM Benchmarking Club, and there is an obvious correlation between really high-performing authorities and low carbon positions. So we would encourage you to focus on VFM improvements as well. Carbon has stayed in the agenda for the FHRG moving forward. Our research priorities are looking at this fairly profoundly across all of the things that we're doing, and most of the research initiatives now have a carbon component to them. So within this, we're seeing, even though carbon accounting for us is now an end of research theme, so it becomes business as usual, we as a research group park it, really, we hand it back to the sector to do with what you will. What we can see here is the interest of authorities is really reshifting focus on that, the political change, but carbon comes with it. So where next? Just to wrap this up for you. The CLP program, I think it's 58 people are currently running on it, as I mentioned. Those are a lot of very large authorities, so we have a statistically significant sample, according to my colleague Andy Perrin. So we probably won't do all 153. We're kind of worked up into a state of apathy about that. As long as we have a sizable sample, DFT can then see who is carbon literate and who is interested in carbon as a topic. We end those returns and we provide that data. But where do we go from here? So the CFA, the carbon footprint assessment, we are probably going to, in future years, extend the boundary. So new services, new regions, new functions, and we're going to extend it into supply chain assessments. We're also going to allow user-defined factors, and we already have the tools for carbon profiling. So we are going to make better use of those components. We're going to extend the factor set for best practice carbon assessments. And you probably no doubt heard rumour, because we're currently trialling and calibrating it. We're building a climate change resilience factor set so authorities can assess how climate change resilient their assets and services are likely to be. All of this in the future will result in business cases. We're going to try and move away from carbon being the reason and carbon being part of an overarching business case, so that every authority in the UK can see a reason for doing something about it. So that's the journey that we're on. Thank you for your time. I hope that was a useful briefing. And any questions, I'm happy to take.
Simon, excellent. Really, really good to see what's going on there. We just have just one question there, This is from Rob Hodgson. Are there any plans to publish the analysis and rank local authorities based on their carbon emissions performance? We hear a lot in the AIA about requirement that parliamentarians always wanting to rank things, put league tables, who's best, who's worst. Is there any plan to do that from your side?
The only people who see the authority names are us, and they will go no further than us. Even DFT will not see the authority names. They will all be anonymised. It is very hard to get authorities to sign up to do a demonstration of potentially shortfalls as a work in progress. And so the basic agreement is, yes, you will be able to see yourself on a league table, but the only people that you will see on that league table are you and a range of anonymised authorities.
Yeah,
that's the only way that will work.
All right, great. Excellent. So thank you once again, Simon. That brings this session to a close. I'm now going to hand back to the chair of the AIA, David Giles, to take us into the final section. Over to you, David.
Thanks very much indeed, Ian. So now on to our final session this morning and the topic of utility reinstatements. Before we get started, though, I thought we'd share this little video, this advertisement from the 1980s by way of a bit of a light-hearted introduction. I'm sorry, I have to smile when I see that, and I hope some of you are as well. But joking aside, there's much changed 40 years on. We know from responses to our alarm survey that there are over 2 million utility excavations a year in England and Wales, and that the quality of reinstatements varies considerably. And we know for some of you, it's a major issue, but for others, not an issue at all, with a great working relationship with the utility providers and contractors. And indeed, some report 100% compliance with the new Roads and Street Works Act reinstatement specification. To discuss what we can do, what can be done to improve the situation for everyone involved, I'm joined by Mark Whitaker, David Capon and Matthew O'Sullivan. Now, Mark is head of the Works Quality and Management Systems at Cadent Gas, which operates over 100 local authority areas in England, and was among those called to give oral evidence in the Transport Committee's recent inquiry into the impact of streetworks. David is Strategy Manager at the Joint Authorities Group in the UK, JAG UK, which provides strategic direction to local authorities in terms of their approach to streetworks, and has worked in various roles in the industry since 1987. Matthew is Insurance and Streetworks Project Director at Network Plus, which carries out reinstatements for some of the UK's major utility providers. Well, thank you to all for joining me. I'm really grateful that you've been able to come today to speak at Sharing Best Practice. Now, to start off with, as I understand it, the Transport Committee came up with 12 recommendations as a result of its inquiry. 9 of those were battered into the long grass by the DFT. The rejected recommendations included, first of all, allowing more local authorities to set up lane rental schemes. Secondly, extending the reinstatement guarantee period to 5 years. And thirdly, tightening the use of immediate and urgent permits, something that I myself am quite interested in. Then number 4, longer term planning of works on street manager being mandatory was kicked into the long grass, as was the appointments of a street works commissioner. So again, thank you for joining me. I'd be really interested to know how you feel about those topics being, or those opportunities for change being battered away by the DFT. So I'm going to go to Mark first of all. Mark, would you like to comment on those outputs and how you feel about them just being put to one side?
Yeah, good afternoon all, and thanks for inviting me along. It's got to say, it's been an absolute great session for me to sit in and listen to, and hopefully we can touch on that towards the end of this. In terms of the TSC's suggestions and the government's return response, obviously I give evidence on the day, and my feelings are still the same as what they were on the day and when I give it evidence. I think there's a lot of legislation currently in place that allows highway authorities to actually manage these works in the correct way. So a lot of the asks on the day, the legislation is already in place where we can manage it. So in terms of immediate works, that's been raised, and it is a hot topic because we see a lot of it going across the country around activities being done quickly overnight. And what I will say is it's utilities, highway authorities, both doing immediate works across the patch in terms of what's being done. In terms of best practice on that, there is areas where when immediate works are started on an evening out of hours, it's that communication things. We've seen today some great communication in terms of sharing knowledge. The relationships between highway authorities, that's where we need to get back to, the basics of actually communicating with each other. So when immediate works are raised and they are going to be impacting road use, it's that conversation piece, picking up a call on that. The legislation is already in place to manage it. We just need to get better at communicating. I'll touch on the other point, which is obviously a hot topic, is around guarantee periods. And Alan Ferguson this morning, he talked around some of the work that I've been doing in Scotland around their assessment of aged reinstatements. And I truly believe we probably need more evidence from the findings of inspection data, coring data, to start looking at the profile age of what is actually failing in what year of its age. Once we get a better understanding of that, I think then there's a better case then to sit down and actually discuss guarantee periods in a better way.
Thanks, Mark. But look, it's not all good, is it? I mean, I hear everything you say, and before we had this session, Matthew and Mark and I had a conversation about the questions that might come up. One thing that's still eluding us here is why were these topics that the appointment of a street works commissioner and tightening up of urgent permits? Let's pick up on the urgent permits. Matthew, could you comment on that? I mean, why is it that we aren't seeing more control around the use of immediate and urgent permits?
Yeah, so I think in a lot of cases, work will get promoted by our clients. So I suppose I'm on here talking from a contractor community perspective, but works will come in from a customer, as an example, if they've got a leak outside their property, promoted through our clients, and then it will get promoted to us. So at the point in time when it comes to us, we'll start planning it, and then we'll drop it onto immediate notice. But I think the frustration is there's a period of time between the customer maybe raising the issue through to us getting the job and then actually putting the permit or the notice on. So I suppose visibly it might look like, well, the job's been out there for 2 or 3 or 4 days. Why is this suddenly an immediate job? But the reality is, we're picking up jobs, planning it based on when we actually receive them, and reacting accordingly. So I think there is a gap there that always needs exploring. Just picking up on what Mark said, that the relationship back with the local authority is absolutely key. And in most cases, we have supervisors allocated to areas. They form a really good relationship back with a person in the highway authority, so they can make the phone call. We've got this job. It's urgent because of this reason, and that's why we're dealing with it in that manner. So we really would encourage those relationships to happen. In some cases they can't happen because our clients want the communication to go directly through them and not have that direct relationship. But obviously we always try and break down that that bridge to make sure we have got that direct contact, because at the end of the day, if something happens during the night or over a weekend, you know, we need the ability to contact the local authority, have that conversation.
Yeah, thank you, Matthew. David, yeah, the topic of communication came up. Why not have a streetworks commissioner, as there is in Scotland, and mandate or at least put better structures in place to improve communication around these works?
I mean, the commissioner in Scotland has the powers to fine for poor performance, etc. What we actually need, I think, whether that's a commissioner or whoever, I think the industry just needs to refocus itself. We need to start looking at incentives. We need to start looking at, I mean, lane rental, love it or hate it, incentivize people to look at a piece of work and change the way they're going to do it to cause less disruption. A good lane rental scheme should have no income whatsoever, because then it's working as it should do. It's not about the money, it's about driving the behaviour change and driving things differently. I mean, you go back to that Heineken advert and we all smile and laugh at it, but what actually we should be doing is not digging holes at all. Why are we not investing in trenchless technology? Why are we not changing our thinking? What we're doing as an industry, we're heavily regulated, and some of that probably needs another look at. We just need to change how we approach the whole thing. And I think then we can sort of restart and get ourselves get back into what we should be doing, which is providing everybody with a better service.
So Mark, do you feel that we are suboptimal at the moment, that what we get in our alarm survey showing that, you know, we get this range from, yes, we get some local authorities reporting really good quality collaboration and works, but then we get a real extreme, which is one of the reasons we brought this topic up. Give me your view on where we are. Calibrate me between really bad and really good. Where do you think as an industry you actually are?
Yeah, I think we can use stats all day long to paint a picture, but you know, from the Cat C inspections and the guarantee period inspections that we see across the country there, on a whole, we're at 92% compliant in terms of visual inspection. So we haven't got a major issue with the quality of reinstatement that's put down there. That's not to say there's bad examples of it, because there absolutely is, and there will always be when you're relying on hand laying material within our weather conditions across the country. What I will say is I agree with Dave there in terms of, you know, going back to some basics at the moment. We've got a lot of regulation in and we're restrictive, and listen to your calls this morning or your speakers this morning, which were fantastic. You know, I'm almost jealous in a way, because on the utility side, we're so restricted in terms of what we can do innovation wise. We're restricted in terms of materials we can use. So listening to all these different examples going on across the country, I'm really jealous. And my ask would be, how do we start working together, you know, not in silos, as highway authorities and utilities, to come up with an easier way of doing work and getting the quality to where we need to be? Because the consistency of putting material on the ground, it should be simple for us all. We dig an excavation, we reinstate it, should be same, not, you know, 105 different ways of doing things. So I think I'm completely agree with David. We look at it and see what we can do.
So Matthew, Matthew, do you agree with this, that, you know, this is more about opening up the opportunity for technology, looking at things in a different way?
Yeah, absolutely. I think, you know, if you put things in context, you know, the vast majority of our reinstatements we do, they're not done on a pave layer. You know, they're not, you know, even done through using a hot box. The vast majority is done off a 7.5 ton vehicle. You know, and the guys are going in the morning, picking up material, and then during the day, obviously using that material. And the reality is there's a vast amount of quality checks that happen through the process, from checking the temperature when we pick it up at the plant, making sure that the temperature's right at the site. You know, I mean, I'm on the Streetworks UK board representing all the contractors, and there's 25 contractors on that group, and they've all got, or we have all got, things like apps that the guys have to fill in, you know, which kind of record the temperature when they arrive, the layers that they're laying, they're putting the material in, number of compactions, you know, a whole load of tests, and, you know, with photo and questions and answers that they have to fill in, you know, the level of QA that I suppose we all go through to try and get it right is really significant. And that's not to say that we don't, you know, we don't get it wrong sometimes, because clearly we do. But I think just for context, you know, we've got a lot of people out on small vehicles laying small utility patches, and the challenge is always to try and get that quality up. And myself and Mark have done a whole load of work over a vast number of years, you know, to produce recipe cards, you know, that are easy and simple for people to use, doing training sessions, briefings, etc., just to try and drive that quality up. But as Mark said, you know, we're dealing with different materials and different locations that are different on different days, you know, so there's always challenges around it. But I think it's working together, that collaboration thing, really important. And, you know, innovation and all the stuff that's been talked about today are going to feed into that and just make it better as we go forwards.
Yeah, David, one thing we work very closely is the AIA with the Institute of Highway Engineers, who I know are very concerned with training in the broader industry. I'd like to hear from you about training and how this is affecting the reinstatement of these openings. I mean, anecdotally, I myself have driven past varying quality of subcontractors working on reinstatements. Are we doing this well enough? Is that well regulated and controlled?
I would say it's an area where we could do much better. I think we need, again, use new technology, and we've got to train an accreditation process, which probably is not fit for purpose. It's been the same since 1991. We need to sort of we know for a fact that supervisors and operatives don't like going into the classroom that much, don't like looking at multiple questions on a laptop. But there's technology out there. We could do we could easily work using assessments remotely on live sites that people are taking. We need to enhance the sort of continuous assessment. At the moment, we have, you get a street works ticket, 5 years later, you have another go, you know, you renew it. Well, what's happening in between those years? We don't know. Yeah. And I just think it's a whole subject that, and there's a lot more that we could do with this. And again, the DFT were doing a research project on our behalf, but that got caught up in the political change. So it's sort of sitting there waiting. But there is a lot that we can do there. But I still think the answer is that the industry's got to change its whole focus a bit.
I mean, it does. It really resonates with me hearing Mark talking earlier, saying that, you know, he was jealous of looking at some of the other, I think I'm using the right word, Mark, of some of the initiatives and the way in which the industry is working together, which thank you for recognizing that, because there's been a lot of effort from the different organizations in the industry to get there, but very sad that we don't see that in terms of reinstatements. I'm going to ask one last question, and please, if you could keep it as short as possible, because we only have 2 minutes to close. In fact, let's just go to Mark. Mark, can you give us a reason why you think the DFG rejected this 5-year guarantee reinstatement? And that was actually a question that came up on our question board.
Yeah, I honestly think that there's not enough data shared around what we're actually seeing in terms of failure. So I think we touched on it previously around the types of failures that we're receiving at the moment. So there's a bit around reinstatements get failed for scarring in existing footway, which isn't related to the reinstatement itself. So just the mode of failure would be interested. And then if we can plot that against the age of the profile of the reinstatement, then we should be able to come up with, do we actually need a guarantee period? And what does that look like going forward? So I think there's just work that's required there to understand that.
Mark, Matthew, David, I'm going to thank you very much indeed for joining us. I'm really sorry we can't spend more time with you. I myself am somebody who's very keen to see improvements in this area, and I know that you're all advocates for improvement. So thank you so much for coming on and spending the time with us. I'm going to wrap up now because unfortunately we really do have to leave it there. And I'd like to thank all of our speakers for their contributions to this morning, and of course all of you out there for joining us, and the largest number we've ever had. So I hope that's an indictment of the superb presentations we've seen. I do hope you found it useful. We will make recordings of each session available on our YouTube channel, and of course, let you know when they are ready to view. You'll also receive an email asking for your feedback. So please do give us your feedback. That's how we improve and change the session every year. I can see my clock's gone to 1300. I'm not going to stand between you anymore, other than to say thank you to James Reed PR, who are the engine behind this machine moving forward every year. Fantastic job that they do. And also to my colleagues, Ian Lancaster and to Malcolm Sims. Thank you again for joining us. Enjoy the rest of your day, and goodbye.